A very good evening, everyone. This is 4 o'clock, sharp 4 o'clock, and we have started our session on Triple R series, which is your reset, restart, and rebounce. This is our first chapter of chemistry, which is electrochemistry, and I have started taking chapters from 12th standard first of all, so that we can cover all complete physical chemistry at once. Then we'll let you we'll reach to the inorganic chemistry, and then organic chemistry will be done. But our target is of just 2 months, and we have to finish complete syllabus of JEE Main 2025. So this is the only person right now standing in front of you and expressing the all feelings and my point of view to every one of you, that at this particular point of time it's me only who can help you to again reach to the milestone you have set for your life. And do not feel guilty if you couldn't have scored well in your first attempt, or if you did not give your first attempt because of some reason. We are right now have plenty of time, but this time cannot be wasted. Let's come, gather your energy, and then we'll start this session. This is your Triple R session for electrochemistry, and we have the first session here. So guys, everybody please gather around. Those who are not watching it lively and will watch it later on, a message to all of you that right after this session I will provide you 50 very important questions. 50 important questions are those questions which are highly expected to come in your next upcoming shift as well, of your next attempt of April, of this April. Also in JEE Advanced there is a huge possibility of appearance of similar concept and the question. So be very very attentive, and be kind of accept everything and then start your journey. I'll take you to the first part of this session. Before reaching to the first part, let me give you an idea what is this chapter about, what topics do we have to cover, so that we can make our second attempt very well, which we couldn't know in the first session or the first attempt. That is this starts from here, okay? That's a part of redox, but I have come up with electrochemistry. So in redox we already have dealt so many things, and we'll come with redox later on. Now this is our target, okay? So read out every single point which I am gonna to cover in this upcoming session. I am not gonna to skip a single concept as well. Every concept will be covered, every single concept will be covered, and how in the bestest way possible. That I believe you have to make upon on your teachers. Now before, what should I say, unnecessarily explanation of this whole chapter along with practicing questions is a very big task, and it will kill most of your time. So I would like to give you an idea of the concept, and then I'll let you solve some questions which will be asked in the exam. Let's say if we are talking about physical chemistry, numericals are asked so many very frequently, rather than going for theoretical concept. But again, everything will be covered, don't worry. Enjoy the session, won't take more than 4 hours. Let it be a straightforward 4-hour class, and then you will enjoy the session. The first part that you have to keep in your mind when you start this session is important concepts from redox, which are going to be used over here, which are very simple. Oxidation means loss of electron and increase in the oxidation state. Reduction means gain of the electron and decrease in oxidation state. Oxidizing agent is someone that undergoes itself reduction. Oxidizing agent means it is about to oxidize the front species, so it automatically itself will be getting reduced. Very simple. So it gains electron, or I must say it undergoes what? Self reduction. Talking about reducing agent loses electron, means it will undergo self oxidation. Then we have N factor. N factor is the difference in the oxidation states. Let's say if KMnO4 in acidic condition undergoes, this is a half cell reaction I'm writing, half reduction reaction I'm writing, manganese undergoes a change. So here I can explain all the parts. This species from +7 is going to +2. The process over here is reduction. That's why this species will be called as an oxidizing agent, because itself is undergoing reduction, means it might be oxidizing the front species present in the chemical reaction, or the complete redox reaction. And also N factor, if you want to know the N factor, it's always positive. So you got to just find out the difference between the final minus initial oxidation states, and plus 5 will be the n factor. And believe me, n factor is something, that quantity that has to be kept always positive. Nowhere we can take n factor as negative. All clear, guys? All set? All? Yes, sir. All set. Okay. Thank you, guys. So that was just just a start, just a brief of this chapter we took. And now coming to electrochemistry. So guys, electrochemistry is a branch of chemistry that deals with the interconversion of electric and chemical energies and its study, and a device that is used to convert the electrical into chemical or chemical into electrical is called as an electrochemical cell, a battery, a cell. And this cell can also be further classified into two parts. One of them is called as galvanic cell, another one is called as electrolytic cell. A galvanic cell uses the mechanism of chemistry, a spontaneity of a spontaneous chemical reaction, and produces electrical current from this. So more or less we can say that chemical energy is converted into electrical using a galvanic cell. Similarly, a particular reaction that cannot happen without an external help or external aid, that requires electricity to happen, these kind of chemical reactions are also, okay, these kind of reactions where we are using electrical chemistry to carry on a chemical reaction are called as electrolytic cell. A container in which this reaction occurs is called as electrolytic cell. A container in which this reaction occurs is called as a galvanic cell or just a cell. And anode is kept over here in negative sign, and positive sign cathode is taken. Anode with positive sign and negative sign is taken electrolytic cell. Anyways, the overall conclusion from this entire thing which is written on the board is, whenever oxidation occurs only at anode. Remember this part, oxidation throughout this universe only happens at anode. So wherever oxidation is occurring, the electrode will be anode only. And cathode always happens with reduction. So reduction happens only at cathode. So anode, oxidation, cathode, reduction, it's a universal truth. And now we'll see each and every one in the detailed example of this part. So I'll take you to a simple discrimination between these two. So our difference is between galvanic cell versus, I'll take you to electrolytic cell. So I'll explain everything in just like as fast as possible. In just few minutes I'll explain everything, whatever you need, everything I'll be explaining. Galvanic cell. What is a galvanic cell? Sir, a galvanic cell is composed of two separate compartments which are also called as half cells, because this whole setup is a cell. This is called as half cell. This half cell is connected through wire via some external agent, that is none other than a device that we are gonna to use it for, because we know that like that. Okay, so what do we see? That this is a zinc rod, this is copper rod, this aqueous solution is actually ions of copper, means copper sulfate. This liquid over here is aqueous zinc sulfate. Probably all the things that you already know. None of the things are very new and very differently I'm doing. So guys, what I'm taking is this part as negative, this part is positive. This negative part is actually anode, this positive part is actually cathode. The flow of electron takes from this side and reaches to this side, and opposite to flow of electron flows the electric current I. Hopefully this part is absolutely clear to all of you. So now talking about the chemical reactions occurring over here. So at the rate anode you will find oxidation, as we already have recalled this part, that zinc metal solid gets diminished and produces its ion also along with electron. And why is it happening? Because of this connection. This connection generates This connection generates some electrical difference, some potential difference, and that makes this electrode to lose the electron and to gain the electron by this electrode. So at the rate cathode, what you will be seeing, at the rate cathode, we know reduction occurs. That means copper 2 positive present in this solution will acquire 2 electron to produce copper solid. This kind of reactions are occurring here. Anode, this is happening. Anode always occurs with oxidation, and at cathode we always see what? Reduction. This is oxidation, this is reduction. That's the chemical reaction occurring over here. That is your galvanic cell. What is being produced over here? Electron. What is the use of electron? The flow of electron causes electrical current. So we are right now converting the chemical energy of a spontaneous chemical reaction into electrical energy. And where we are consuming the electrical energy? We are using this electrical energy to glow this bulb. And now you can check out, see, this might not be looking to you as a glow-on bulb, but now the bulb has started glowing. Now see, it's a glowing bulb. So congratulations, guys. Now the second part of this session is talking about the next thing, which is your electrolytic cell. The difference is electrolytic cell contains only one container, and in this container we have 2 separate electrodes which are dipped. These are plates, not some metallic wires. These are plates, but you are watching them, you are seeing them, you are looking at them via different angle, and where the angle where they are like thinner, and this projection of this wall is going beyond like inside of this board, and this plate is like inside of the board. But anyways, let's come to the major part of this overall cell, which is your electrolytic cell. This lytic cell is connected with I must call it a battery. This is a positive charge, this is a negative charge. Some metal plate which is connected to the positive charge of a battery will be acquiring a positive charge, which is none other than your anode. This is your anode with a positive charge. This negatively charged plate is called as cathode. The polarity might have changed. You may see, you may watch very carefully. Polarity of cathode anode has been changed here. But the only thing that doesn't change is the process. What process is occurring here, everyone? What process is occurring here? Sir, this process will be no doubt a redox reaction only. But this is a solution. Let's say this solution is molten. This solution is molten sodium chloride. So molten sodium chloride has ions freely available to move there. So what do I see? So at the rate anode. So do you know what is the charge on anode? It's a positive charge. So negatively charged species which is present in Na positive and Cl negative ions, because it's a molten state. The negatively charged ion will attracted by the positively charged plate, so that they go there. 2 Cl negative ions will be going there, producing Cl2 gas along with evolution of 2 electrons, which electrons will be traveling. Where do these electrons travel? Nowhere, sir. Because we are providing them energy, the electrons are traveling inside of the circuit, inside of this container, and reach to the negatively charged plate, which is your cathode. And that's how the electron keeps on moving, creating the electric potential difference between these two. And this reaction, which was not earlier possible to convert the molten NaCl into NaCl2, now is being occurred. So what will be happening? This is actually oxidation. As I told you that the beautiful part of this redox reaction is anode always goes with oxidation, and at cathode reduction will be taking place. How? Let's see. At the rate cathode we have 2 Na positive ions which will be acquiring the same number of electron which received from the positively charged plate of anode, and then producing sodium metal deposited over there. And again, now if you talk about the process, what is happening here? This was an oxidation process, this is a reduction process, and that's how it works. So let's have a look again on the board, and let's try to figure out what is the difference between galvanic cell and electrolytic cell. The galvanic cell basically converts chemical energy into electrical energy. On the other hand, an electrolytic cell converts electrical energy into chemical energy to carry out the non-spontaneous chemical reaction. That's a beautiful example. So hopefully we are clear. We all are clear till this page. Now there is one thing that I want to tell you is the role of a salt bridge. I'll let you know about the role of a salt bridge. What is a salt bridge? How we have to use a salt bridge, and what is the basic use of it? So what happens, guys, as we were earlier aware of this part, that a negatively charged plate, and this is used in only used in galvanic cells. This is used in galvanic cell. What we are talking about? A salt bridge. We have two solutions here, and we found that one of them will be having so many zinc positive ions here. So let me take zinc positive ions as green color. This is your Zn2 positive ions. Okay, on this process is actually accumulation of the charge. So this is accumulated. This is accumulated Zn2 positive ions, and these all are positive charge ion. So the flow of electron doesn't work properly. Similarly, an electron coming from this side, if an electron is coming from this side, and so many sulfate ions will be accumulated on this positively charged plate, because copper 2 positive was deposited, and copper is deposited, that's why sulfate ions will be available in plenty. So these are nothing but the accumulated, they are gathered sulfate ions which are negatively charged, and doesn't let this an electron, external electron, to come in this compartment. It's not letting this electron come, and that's why the flow of electron stops, electrical current stops, and that is called as the charge accumulation. So the very first part, that is the use of a salt bridge, is prevention of charge accumulation. Prevention of charge accumulation. Number 2, what is the use of a salt bridge? To balance electrical neutrality, because what will happen with the time? As the time passes, the electrons will start stopping, will not be able to move from one compartment to another because of the accumulation of the charge, and because of that so many positive charge will be acquired over here of Z positive, Zn positive, negatively charged sulfate ion will be here, and that is what requires a balancing of electrical conduction, or electrical neutrality should be maintained in order to make the flow of electron easily. So we require a hero. A hero is nothing but a inverted U-shaped glass tube with concentrated electrolyte, concentrated plus strong electrolyte, which actually helps to provide the number of ions very easily whenever it's needed. And this is an inverted glass tube, and we call it as salt bridge. So what is to be used in salt bridge? That the cation and anion of same mobility, same moving capability must be used in the this inverted tube salt bridge, and its purpose is to prevent junction potential. So what is junction potential? Whenever these two liquid comes in contact to each other, they are like now having positively charged ion here, negative charge here, a potential difference will be generated between them. And earlier we also chose them the external voltmeter is also connected over there. So basically the potential difference that comes or arises because of the mixing of these two liquid is against to the electrode potential which they are representing or they are producing as a cell. So this thing let's decrease in the efficiency of this cell, and that's why the junction potential should be prevented. So we'll cover in this way only. The prevention of charge accumulation to balance electrical neutrality, prevention of the junction potential, and also complete circuit through internally. So completion of the circuit, completion of the internal circuit. This is your completion of the internal circuit. So anyways, that was not just the applications. We also know what is the purpose, why we are implementing this very important part of this cell, which is called as salt bridge. I hope you all are now pretty much aware about salt bridge, and salt bridge concept is done from my side. Let's start solving some questions based on salt bridge itself. Potassium nitrate is a solution, and why we are using it as a electrolyte in the salt bridge, because once it's a, first of all, it's a strong electrolyte, and not just strong electrolyte. First of all, it's a strong electrolyte. Along with this strong electrolyte, the mobility or the velocity by which potassium ion will travel will be similar to the velocity of nitrate ion, so that what will happen, at the same time they will be reaching towards the required compartments, and that's why it doesn't happen where like so many ions are in one side and then another side is getting deficiency in the some another charge. So that is what it keeps on maintaining the level neutrality, so that any junction potential doesn't arrive. Then we also have the size is greater. No, size difference shouldn't be there, velocity difference shouldn't be there, velocity should be same, and they are not worried about the sizes are pretty small for all the ions. We are now coming to the next part of this session, which is your half-half cell reaction. So it's right now what we are studying about is galvanic cell in a bit detail, and then we'll start solving some problems, because there are plenty of questions have been asked even in this year of JEE Main. So I'll let you know, but before that, let's start solving a simpler part, which is called as half cell and cell reaction. So how can we identify the half cells? So we already are given up with the main cell reaction. This is called as your main cell reaction. So main cell reaction is actually complete cell reaction, in which you can also identify which portion or which part is been undergoing oxidation and which part is undergoing reduction. So copper in 0 oxidation state, silver is in +1 oxidation state, copper is in +2 oxidation state, and silver is in 0. Something from 0 going to 2+ is actually undergoing oxidation, and something from +1 oxidation state going to 0 is undergoing reduction process. So now once you know oxidation and reduction, you can simply apply both the half cell reactions. Like first of all, what is your oxidation half cell or the oxidation half reaction? How do we write the oxidation half reaction? So oxidation half reaction is copper, which is from 0 oxidation state going to Cu2 positive along with evolving 2 electrons. What is the reduction half cell here? So that is how we are converting a given main reaction into half reactions. So reduction half reaction will be what? Zinc 2 positive accepts 2 electron and zinc is prepared, and not zinc, yeah, this was silver. So Ag positive accepts 1 electron and then Ag is formed, right? So that's how you can convert them. And this is reduction, this is oxidation. So this might be happening at, this is happening at the rate anode always. This might be happening at the rate cathode. A student is asking me, so sir, is it enough for advanced? That was, I guess, a very relevant question. Pardon me, brother, but whatever the lecture we bring over here, these are not just for JEE Main. A person who is highly dedicated and know how to find out the ways, these are extremely enough lectures for your advanced preparation as well. In this pretty much chapter, I have also incorporated some advanced level problems and in my tomorrow session. So everybody, those whoever are watching me right now, let me be very clear. Right after finishing of this lecture of this 4-hour journey, I told you, I am providing you absolutely, I will be providing you how many? 50 questions, most important expected 50 questions, not for just JEE Main, also with JEE Advanced problems and some good level problem, which will be giving you as a homework, and you may try those problems by your own. And once you are getting done with these problems, come in my tomorrow shift. Link is given in the description. There will be a special class. We call this as special class on Unacademy application. Link is given. Just a simple formalities will be done. Enrollment will be done. It's absolutely free, of course. None of the class will charge you anything. So just freely go there, enroll yourself for the class. And my class is in the description right now, given over there. The link is in the description. And then I'll take all of your doubts, whatever the doubts you face, and that is a platform where you can talk to me as well. You can directly raise your hand, I'll let you speak, and then we two can be connected over a call and can speak meanwhile of the class. So you can come up with your doubts along with the proper practice session will be held there. So now attend your lecture, stay confident, keep your faiths on your teachers, and that will create a success anthem then. Half cell and cell reactions were we doing there. We were earlier doing one part where in the complete cell reaction, we were abstracting out the half reactions. What if the half reactions have been given? Let's say we are given with the half reactions, Al3 plus is going to Al, Cu is going there. Then how can we club them and can form the complete chemical reaction? So it's very simple, guys. As we all know that at the rate anode always oxidation occurs. So at the rate anode oxidation half reaction will be there. Aluminium and copper. So aluminium is shown here going from 3 positive to Al and copper from 2 positive. Okay, anyways, we'll discuss it later, a bit later, that for a spontaneous working of a cell, the particular cell potential or particular electrode that has, or this metal which we are writing, aluminium, copper, the one which is having higher reduction potential will be always treated as cathode because it has a self tendency to get reduced. Anyways, coming to anode, Al will be oxidized to Al3 positive, producing 3 electron, and the process, as you all can see, is oxidation. Similarly, at the rate cathode, we know that reduction occurs, reduction of copper 2 positive ions accepting 2 electrons, forming copper metal will be taking place, and then overall cell reaction is very easy. Whenever you go for the overall cell reaction, you make sure that the electrons in both of the sides should be equal. Let's multiply it by 3, let's multiply it by 2, then it will become 6. So it will become 2 aluminium plus 3 Cu2 plus produces 2 Al3 plus and 3 Cu. This is your balanced chemical equation, and not just balanced chemical equation, we also call it like overall cell reaction. This is your overall cell reaction. Anyways, that was just a simpler part of this chapter where we were trying to do two things. One of them is, if the main reaction is given, how to abstract out the half cell reactions, and if the half cells are reaction, how to make out the make the complete full cell reaction. That is a part of this cell, what galvanic cell was we were like talking about. So now I'll tell you how to represent the half cell somewhere, right? Problems like usually people know how to basically do it, but they can't do it in the questions. So I like to know what is the procedure, how can we reach to the correct representation of a cell. So guys, we all know that left hand side, and then we have salt bridge, and then we have right hand side. Always make sure that in left hand side we got to write down the anode, where we know that oxidation takes place. There comes the salt bridge, and there comes the cathode. Cathode happens with reduction. It's that simple, right? Let me take you to one example. We call this cell as Daniell cell. Daniell cell. What usually happens at Daniell cell? Zinc being oxidized, reduction takes place on copper. Cu2 plus ions are being reduced. How do you represent it? So there's a very simple part. Let me show you this part. And rest everything is written there in the theoretical way, but I'll explain you in just 1 minute. Quickly, very quickly. Sir, zinc in its solid state gets converted. So whenever something gets converted to another form, we have to put one vertical line like this. And then becomes Zn aqueous. Whenever any aqueous species there, you need to mention how much molarity is given to that. Like, let's say this is given you 1 molar. Let's say simply. There comes salt bridge right after finishing one component. One component of anode has been completed. As I told you, anode is written in the left hand side, cathode will be written in the right hand side. Meanwhile, in between of anode and cathode comes the salt bridge. Everything is set. Yes, sir, very much set. Coming to copper. Copper was earlier in Cu2 positive, which is an aqueous state. If an aqueous state is there, there should be molarity, and that molarity, let's say here is 0.5 molar. Anything is fine. And then you put a single vertical line. What is it representing? A change in the physical state. From aqueous state, it is going to copper solid. That's we have to write it. Very simple, guys. Very simple. Let me take you another example that will make you more fascinated about this topic. Let me take you another example. Very simple example. Okay. Let's say we are trying to make a hydrogen gas and Zn and H2 cell. Now might look a very different to you, but it's very easy. That zinc is undergoing oxidation, so Zn solid will be written down in the left hand side, forming this single vertical line representing the physical state differences between solid and aqueous. And then we need to also put the 0.5 molar, let's say any of the molarity has been given. There comes the salt bridge with double vertical line, and then comes the components of written to be in the right hand side. So what should I write in the right hand side? Cathodic part, where what happens in the cathode, sir? H positive. Now try to understand, guys, what's happening over here. Try to understand. Reduction is happening. So H positive from aqueous state, let us suppose this is 1 molar, and now it is going to H2 gas. So there is a physical state difference, and I have put one vertical column over here. So that's how it is represented. But anyways, this example was not too good, but I can give you some more example, and that will definitely help you to understand the whole concept. So let's see, one more example is there. So in this example, what I'm taking is, okay, I did one thing over there incorrectly. Not incorrectly, but let me just explain that part. So whenever ions are there, gas is there, gas, ions, everything requires a particular support of an electrode. So somewhere electrode itself cannot be hydrogen gas. So we have to give it a support of a metal. So we will be writing there. It's all clear, but along with this hydrogen gas, I'll put a single vertical line representing platinum solid as a electrode. So platinum solid I have added. So I'm star marking again. This is a huge concept. Just try to pick it. Let's say the similar example is given to you, and the example says that somewhere KMnO4 reacted with iron 2 positive. The reaction happened and iron got oxidized, Mn got reduced. In this reaction, what do you see? That potassium permanganate from positive 7 state and iron from positive 2 state, iron reached to positive 3 as an oxidation part, and manganese reached to positive 2 from 7. So this is actually reduction, but this part is actually oxidation. So we know where oxidation occurs at anode and reduction occurs at cathode. So now let me say, let's just write this concept, and let's say this is your concentration. This is also aqueous, this is also aqueous, this is also aqueous, and this is also aqueous. So let's say somewhere we are also writing there molarity. Let's say its molarity is 0.5 molar, 0.1 molar, 0.2 molar, and 0.2 molar. Let's say anything you may take. Okay, at a random condition I've taken it. So now let's say if this cell has to be represented in our way, how do you need to represent it? How are we write it? How are we gonna to write it? The cell representation. So the cell representation is done using anode in the left hand side. What is present in anode side? One which is getting oxidized, which is iron. So I'll write iron 2 positive. Now try to see everyone, which is very important part of this session. This is aqueous state. We know that, let's say this is 0.1 molar. Single arrow not required. Just simple comma is fine. Why? Because the another species it is going into is also in aqueous state. Because since both of them are the aqueous state, we are not providing it a single vertical line. You may provide it or may not, depends upon the options given, but usually we don't provide it because a comma is simply fine that what is going to what. And let me write its molarity also like that. Then comes what, sir? There comes the salt bridge. We all know anodic part is done, oxidation is done from iron 2 plus to 3 plus. Then comes what? Then comes the reduction part. Where is the reduction happening? Sir, MnO4 minus ion, which was already in positive 7 state. It is not just aqueous, it is also 0.5 molar is now undergoing reduction. But no need to put down that thing. Its comma is just fine and undergoing to change in oxidation state from Mn7 plus to positive 2 plus. Aqueous and its molarity is actually 0.2 molar. Now the question is it completed? It's not completed because none of the half cell can be allowed to have simple ions or gas. There should be a metallic conductor which is required to carry the electrons from one compartment to another, and that's why the support must be written, because it's a different physical state. Now we have to apply one single vertical line. Where? Here, sir. What? Let's say this rod be platinum solid, and at the end we also see just simple ions are there. Put a single vertical line, put a platinum solid, and that's how we represent everything. I'm star marking this because it's an important concept. It's a very important concept. Sir, where to get the okay. So don't worry guys, that will be provided very soon. Now it's a first lecture, just enjoy the lecture. Make sure that our bonding, our tuning is matching. We are at the synchronized pace, and then right after that I'll also provide you 1 week prior, at least every week prior I'll provide you what chapter has to be covered in this upcoming way. But now it's very simple that now we are covering physical chemistry of right? I'll try to take 2-3 lectures, 2-3 chapters. I'll try to club 2-3 chapters. Probably in our upcoming session, I may include both of the chapters together, solutions and solutions and chemical kinetics, because chemical kinetics and solution both are small level chapters, small size chapter. This is a bigger chapter. That's why I took this chapter alone. Anyways, that was the presentation. Now I'll take you directly to one question, and where you can answer this question. In this question, it is another redox reaction that we can see, and we also need to identify which is undergoing oxidation. I think iron is undergoing oxidation from positive 2 to positive 3, and the same way dichromate ion from positive 6 oxidation state of chromium undergoing a reduction in positive 3. So we know that this has to be the reduction part, this is to be the oxidation part. This is which is happening at the rate anode, oxidation at the rate anode. We also know the another part, which is this part, and this is actually reduction might be happening at the rate cathode. Now matching both of the things, what we can see, the correct answer is anode in left hand side, platinum 2 plus, and going to this. I think this is absolutely correct. Our first option itself is correct, because they also provided this is needed somewhere. Platinum extremely left, extremely right, that's what you have to put about. Got it guys? Next important topic of this concept, what we are right now learning, this is called as galvanic cell, and galvanic cell has another important term that is called as reduction potential or electrode potential. What is the meaning of potential? So don't take unnecessary panicking and problems. We are in chemistry. Let's leave chemistry like what we have to do specifically for chemistry. Don't go in physics and unnecessarily introduce the concept of electromotive force, potential differences, and V equals to IR, Ohm's law. That will come. Anyways, that will be coming. Electrode potential. What is electrode potential, by the way? So let us suppose this is a half cell I try to make. This one is a half cell I try to make. This is a metallic electrode, or this is a metal rod, let's say, capital M. Metal with a symbol capital M, iron with Fe, metal with M. And let's suppose there is a solution filled inside this which also contains metal ion. Okay, this is the aqueous solution containing what? Mn positive aqueous, like that. Everything is clear, guys? So what's the possibility that may happen there? So there's a one possibility which is called as oxidation potential. Oxidation potential, and we represent it like E M from zero state to going to Mn plus. This is called as, this is the representation. It oxidation potential is represented by E. This is reaction. What reaction will be happening there? Some metal which is present in zero oxidation state loses its n electron and gets converted to aqueous Mn positive, and this was solid. So what is the another possibility, sir? Another possibility is the reduction, called as reduction potential. What happens in the reduction potential, sir? So the same metal N plus will acquire, this aqueous ion will acquire number of electrons and will be converted into M solid, which is a deposited solid metal. That's it. How do you represent the reduction potential? By EMF E. What is happening, sir? Mn positive undergoing a change in M. That's what we have to do. So this is the representation and a very important part of this session. Please, you must know that oxidation reduction, both of them are important part, and not just important, highly important. Okay, now we have covered it till here. So what has IUPAC suggested us? Okay, and how come these two things are related? Okay, so let me remind this part also, that whenever we write that EOP, right, what is EOP? That oxidation potential of someone is also equals to the negative of ERP. EOP is equals to negative RP, or you may write that ERP is also equals to negative of EOP. So for an example, if I say that E of Zn2 plus going to Zn is negative of 0.70 volt, then E of Zn to Zn2 plus will also become what? Positive of 0.70 volt. You also know one part, that whenever it is written 2 plus 2, this is actually your reduction potential, and this one is actually your oxidation potential. So have a look. So there is one more part that we do. Whenever we use this part, E naught, it becomes standard potential. So when we have to use standard potential, but first you know one thing, that as per IUPAC, International Union of Pure and Applied Chemistry, only standard only reduction potential is considered as, reduction potential itself is considered as cell potential or electrode potential. What we are writing? Electrode potential only, yeah. It is considered as cell potential or electrode potential. No oxidation potential. We don't need to use no oxidation potential. But in case if it is needed, if needed somewhere, then you can make that E of oxidation potential as negative of E of reduction potential. That is what we can use. So a very important part of this session, I told you that we are not supposed to consider the oxidation potential anywhere. The data will always be given in the terms of reduction potential, or we got to check the question twice. If somewhere it is given in the oxidation also, then also we have to take this thing accordingly. So accordingly things will be done. Okay, this is called as standard potential E naught. But E naught, whenever this naught is there, what is the meaning of this naught? That temperature is maintained to 298 Kelvin, or we can call it 25 degrees Celsius. Whenever this has been given, the concentration of M positive, X negative, whatever the ion is there, that we have to consider as only 1 molar. 1 mole per liter. 1 mole per liter. Molarity should be 1. And whenever any gas is mentioned to you, the pressure of gas becomes equals to 1 atmosphere oblique 1 bar. 1 bar is perfectly fine actually. 1 bar and 1 atm are quite near to each other. And in this way, R value, which is called as universal gas constant, will also be become equals to 8.314 joule Kelvin inverse mole inverse. So please have a look on this, try to note down everything, and I'll come in 1 minute and we'll catch you. So meanwhile, evening snacks are very much useful, and all these complementary you should take. Even meanwhile of this study, I used to eat a lot while I was studying. Now let me get through this part and directly take you what EMF of a cell depends upon. EMF is electromotive force, or it can also be called as the potential difference that is arised, but when one half cell is being connected to standard hydrogen electrode. Anyways, what is standard hydrogen electrode, how to use it, that's the next part. First of very all, these are the parameter that which upon it depends. Nature of the electrode, what electrode is there. Zinc will be having different than iron. Concentration, as the concentration dependency will be explained by Nernst equation. So anyways, this all will be learnt in Nernst equation, N-E-R-N-S-T, very soon. So this is what I'll be revealing about in Nernst equation very soon. So now I'll give you one more part, that how do we identify the electromotive force of a cell. Till now we were discussing about the potential differences of the half cell, but now how to find out the aim of a cell. So we know that E naught of the cell, let's say we have to find out under standard condition, it will become what? E naught of cathode. Something might be happening on the cathode, something might be happening on anode. Very simple. But we know that at cathode we always have SRP. At anode what happens? It has reduction there, it has oxidation there, it has become SRP plus SOP, right? But as I told you that SOP can also be written down in negative of SRP, so it will become negative of E naught of anode, but there what we have to use SRP, and we will be always using what? SRP, standard reduction potential, and this has become what? E naught of cell. Now please look at this formula, learn it, it's very important, very, very, very important. Try this question. So what do we see? What is left? Anode. What is right? Cathode. Galvanic cell we are talking about, and its electrodes. E cell. Only reduction potential have to be used. SRP. So E cell will be E naught of anode. Sorry, cathode minus anode is the formula I told you. Cathode is SRP minus E naught of anode, that is also SRP. And we also know one more thing. This is what right, this is what left. So right minus left is the correct answer. Where can you see right minus left? This. So now there's one more thing I want to add here, that how can we identify the half cell of a particular half cell? Like how can we identify the E naught reduction potential? So how to find SRP, what we were earlier discussing about, of any half cell? Because it's not very easy to identify, because until or unless we are connected with some voltmeter or in some closed circuit, we can't identify the SRP. So what we are doing is, we all are aware about this thing. So this is called as your zinc rod. This is your aqueous zinc sulfate solution. Let's say I'm taking it as 1 molar. This is negatively charged electrode. On the other hand, we have one more cell where Inverted glass tube is used. And along with this glass tube, there is a metallic wire going like this along with the metal plate. And these two are connected with a voltmeter, which is about to read the voltage so produced in this setup. So guys, what are we having here? We are passing hydrogen gas at 1 bar. We are maintaining a constant concentration here of H positive ion. Let me write it. This is your aqueous HCl with 1 molarity of the concentration. This white colored wire, what we are seeing, this is a platinum wire, and this one is a platinum plate. So again, this will be giving us a reading of E0 cell. If we are maintaining everything under standard condition, this will be giving an E0 cell. What is E0 cell? Cathode minus anode. What is cathode? H2. But we always need to write it in SRP. H2, SRP minus E0 of Zn going to Zn2 plus. No, Zn2 plus to Zn, because everywhere we only can write the SRP. So guys, when we try to solve this equation, this will give us some value. So the E0 cell, let's say here came with, so this is something that we always have to kept 0, and this value can be identified. So let's say E0 cell is coming like negative of 0.70 volt. E0 of cell will become what? No, anode was this, no? It is coming positive, by the way. This is coming as positive this. So E0 of cell is positive this. That means E0 of Zn2 plus to Zn SRP is actually equals to negative of, sorry, negative of this came 0.70 volt. So this will become what? E0 of Zn2 positive. That means standard oxidation potential. How much is the oxidation potential? This is positive 0.70 volt. So that's how we can find whatever it is required by considering a hydrogen electrode with you, with 1 bar of the hydrogen gas bubbled through it like this, along with 1 molar HCl solution we are having. This is called as JEE, standard hydrogen electrode. So let's have a look on this and then I'll explain what JEE. Who is JEE? Who is JEE? So JEE is amazing, but JEE is standard hydrogen electrode. Nothing apart from this. So JEE is basically a reference electrode. JEE is called as a reference electrode that we have to use to identify the electrode potential of the unknown one. And using this information, once we are finding out for zinc, we can also identify it for any kind of element present in this modern periodic table, and their reduction potential, oxidation potential, everything can be calculated. So all of the reduction potential values are given in this list, which is having a decreasing order, or like in an increasing order of the electrode potential, and decreasing the positive character, electropositive character, going from up to down. What we can see that lithium is supposed to have the strongest reducing agent. Something which is stronger reducing agent means itself it will get oxidized, and it has the highest tendency to get oxidized, right? So stronger reducing agent as what? Lowest SRP. Similarly, you come down and there you have fluorine with highest value of SRP and becomes strongest oxidizing agent, because something which has a tendency of getting self-reduction will be having a higher tendency to oxidize something. So this is actually this is your maximum SRP. So that's what you have to learn. but I would like to give you an idea that you should learn this whole series to compile the data in your mind. Just simply have that order in your mind. Okay, one of my friends suggested me a way. If you want to learn that way, you may learn it. I can give you this way. My friend once suggested me that if you are on high protein diet and if you want to gain your muscles back, do this exercise. What is this exercise? Lychee, kela, banana, kaju na mango, आलू जिंजर करी फेंको सीढ़ी को, नीचे सुनहरा पाव है, कुत्ता इंसान होगा, आगे पालतू और फालतू. What I'm saying about is, this is your लीची, केला, बनाना, काजू ना मांगो, काजू ना मांगो. Put a full stop here. आलू, जिंजर, करी, फेंको सीढ़ी को. फुल स्टॉप. नीचे सुनहरा, we also call it golden, पाव है. पाव मीन्स पाव भाजी. then again कुत्ता इंसान होगा आगे पालतू और फालतू. So it's a mixed of Hindi English, guys. It's a mixed of Hindi English. Please try to resist it. So what we are doing is, you got to learn this whole thing into 4 segments. Okay, just revise these 4 segments along with me. One is lychee, kela, banana, kaju na mango. Lychee, kela, banana, kaju na mango. Na means no. Don't ask for these fruits. लीची, केला, बनाना, काजू ना मांगो. आलू, जिंजर, करी फेंको सीढ़ी को. आलू, जिंजर, करी फेंको. Feco means to throw it away. And where we have to throw it? On the stairs, on the staircase, so that birds like moving here and there can eat the food that you are throwing away. So आलू, जिंजर, करी फेंको सीढ़ी को. आलू, जिंजर, करी फेंको सीढ़ी को. आलू, जिंजर, करी फेंको सीढ़ी को. Why we are throwing the food? Because नीचे सुनहरा पाव है. We have a golden पाव with us downstairs. So नीचे सुनहरा पाव है, नीचे सुनहरा पाव है, नीचे सुनहरा पाव है. And then last, कुत्ता इंसान होगा आगे पालतू और फालतू. कुत्ता इंसान होगा आगे पालतू और फालतू. That means, I don't know what does it mean, but कुत्ता इंसान होगा आगे पालतू और फालतू. So this is your hydrogen that comes with 0. It's, if you talk about the hydrogen, E naught H positive to H2 will be equals to 0 volt. So we are not having its absolute value is 0, but it has been taken as 0 as a reference one, so that whatever the value you find out in the modern periodic table or periodic table, electrochemical cells, whatever the value you find, it has been calculated using E naught of H plus to H2 as 0. That is what we have to follow. Now let me take you that whenever you come from down to this series, this electrochemical down to this series, we are having decrease, E naught value and the standard reduction potential value increases. If something is actually experiencing increase in SRP, this is the lowest value as I told you, and let me check the values as well. 3.05, 2.87. This is your E naught of Li plus to Li. This is your negative of 0, 3.05 volt. And this is the most that E naught for fluorine. F2, F2 to F negative is actually, we don't need any balancing over there. So it's like 2.8387. This is the most Okay. So once the standard reduction potential keeps on increasing going down the group, what happens? The strength of oxidizing agent increases and strength of reducing agent decreases, like that. Just go through this series, try to learn it by your own, gain your confidence and have a command on this series. So what do you find the strongest oxidizing agent in this series? The one with the highest value of E0 SRP, which is your none other than fluorine. The strongest oxidizing agent is this fluorine. Reducing agent is lithium, because lithium has the smallest value of E0 SRP. And if something has the lesser SRP self reduction, it will be having higher self oxidation. So somebody can go oxidation, the front species will be reduced. That means it's a good reducing agent, like that. Go through it, try to remember this, regenerate it, and then stay confident. Next, what is the application of this series? Always remember, the above one is having lesser value of SRP. That means it's a good reducing agent, and the lower one to it will become a stronger oxidizing agent. Okay. We also have a choice of anode and electrode. So guys, you all know that this is an element A and this is an element B. This has what? More SRP, standard reduction potential. Make it a cathode as a choice of cathode. And the one which is placed above will be what? Less SRP and more SOP. Definitely it will be having what? Higher standard oxidation potential, means value a tendency to get oxidized. It will become what? Anode. Also, the metals which are placed at above position can displace the lower placed metal from their salt. Take an example, everyone. We till now has taken this example carefully. CuSO4 and zinc, aqueous and solid, produces copper plus zinc sulfate. Zinc sulfate is aqueous and this is solid. But if you write the same reaction in the opposite way, let's say silver plus copper sulfate, Ag2SO4 plus Cu. This is not feasible. This is feasible because silver comes below copper. Kutta insan hoga aage, then comes Ag. Got it, guys? And also thermal stability of the above placed metal oxide will be higher than lower one, and metal placed above the hydrogen can release hydrogen gas on reaction with the dilute acids as well, as it can replace hydrogen from its salt. Now try to solve this question. There are some standard electrode potential values for aluminium, silver, potassium and chromium, and there are the values given like this respectively. What we have to find out is the correct order of reducing power. What is the meaning of reducing power? Somebody having reducing power means it is working as a reducing agent. Power means it is working as an agent. Agent will be having higher self oxidation or oxidation potential. That means they will also be having what? Lower standard reduction potential. The one which is having the lower oxidation potential will be a stronger reducing agent. So you just need to verify all these values. Where can you find the minimum value of SRP? I think minimum value of SRP is for potassium, which is coming to 1 to 3. This is the minimum. Minimum SRP. This is actually what? Strongest oxidizing agent. So that is what you have to follow. The potassium will be the highest, then the next lower is 1.66 for aluminium, and then we have next is for 0.7 for chromium, and then we have aluminium. Then we have for silver. So the correct answer should be, I think this is correct. Potassium, aluminum, chromium and silver. Another question. Standard oxidation potentials of half cell reactions are given below. So wherever you find the maximum value of SRP, maximum value of SRP, I told you, whenever you see the maximum SRP, what does it mean? Maximum SRP means it's the strongest oxidizing agent, because it has a tendency to get reduced. Itself will be getting reduced, so it will become strongest oxidizing agent. The correct answer is fluorine. First should be fluorine. And also, if you reverse down the all reactions, let's say if I reverse down all of them, so it will become what? 2I negative gives you I2 plus 2 electron. So now this has become what? This process is actually what? Oxidation. If this process is oxidation, this is a reducing agent. Got it? Talking about the reducing agent capacity. So this is called as the SOP. So this is what, if I write down this E0 SOP oxidation potential, what is the SOP? It's negative of 0.53 volt. Just reversing down that part. And if I write down the same thing, that F2 and like 2 times of fluoride ions are undergoing oxidation, producing F2 gas along with 2 electrons. In this particular reaction, the E0 of standard oxidation potential comes up as negative of 2.85 volt, which is making it a weak. This is a strong reducing agent, and this has become what? Weak reducing agent. So correct answer should be I minus and F2A. Please go through the questions once again. Try to learn what is it being asked. Try to understand what has been asked, then reply and then get the correct answer. Chalo. We have a simple question here. A button cell functions as follows: zinc and silver oxide and water are undergoing some blah 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 is happening. So what has been asked to us is we have to give her the cell potential. Do one thing, you find out where oxidation reductions are happening. This is in 0 state, this is in positive 1 state. This is going to, water is working as a medium only, not doing anything. Silver is in 0, zinc is in positive 2. Only observe these two, that zinc is undergoing an oxidation state change from 0 to +2. That means oxidation is happening, and oxidation happens at the rate anode. Similarly, positive 1 to 0 happens, it's a reduction, and it happens only at cathode. So reduction at a cathode, oxidation at the rate anode. So now we'll find out E0 of the cell will be E0 of SRP minus E0 of SRP. What is this SRP? SRP, this is of cathode minus anode. Now what is the value of SRP cathode? SRP cathode is cathode 0.34 minus of 0.76. We'll be adding them 1.1 volt positive. Next. Okay, everyone, please have a look. This question was asked in JEE Main 2025 this year itself. A couple of weeks back, not just a couple, it's just a single week back, 1 week back, this question was asked. Question is simple and says that which one of them is acting as a strong oxidizing agent, and this value can only be taken if we are given with the value of their standard reduction potentials. This is 1.71. This is always the one which will be having higher strongest reducing agent is what? The one which is having higher reduction potential. So this is reduction potential is higher. That means it can work as a oxidation. Okay, which one which is act as a strongest reducing agent? This is wrong actually, but not a problem. Not a problem, everyone. Let's say some values are given to me. So reducing agent means what should it have? It should have highest or most SOP, because something is a reducing agent, it will automatically or itself will get oxidized. Something is getting most SOP, will be having what? Least SRP. And in every single case written down over here, we are only seeing the SRP values. Where you can see the least SRP value, I guess the least SRP value is for E naught this, right? I'm not sure whether this data is correct or not, but actually this is incorrect data. Least SRP, as I can see, is of standard potential is given for all of them, and the least one is given as 1.38 for Cr2O72 minus. So I don't know whether this data is correct or not, but I think the question was not asked in this way. So let me just change the question and change the question as, because these are the memory based question, right? These are not the exact question. Let me change the question to oxidizing agent. Then let's see what is the correct answer. And we all know these all are in positive. These all are positive. Now tell me the correct answer. Now you can find out. Oxidizing agent is the one which can have, oxidizing agent has what? Oxidize, the front species self will be reduced. So highest SRP should be there. Highest positive SRP should be there. Now can you tell me where you can see the highest positive SRP? B is the correct answer. No. It's MnO4, permanganate ion. So well, that was a good question. By the way, we had from JEE Main 2025, this year itself it was asked. Next comes a very important part of this chapter called as relationship between Gibbs energy and cell potential. So anyways, it's a very simple thing. So I'll explain it over here. So guys, do you know what is the work done by a cell? Work done by cell is taken as negative, which is also equals to charge multiplied by potential difference. That's a formula we study in electrostatics. That's work done by a cell should be negative. Should be to carry out the work. So anyways, what we are having is charge into potential. So what is charge, by the way? No idea. What is potential? No idea. So number of moles of electron transferred into mole of 1 mole of electron has a charge of F into potential difference will be E naught of cell. So that is the work done. Work done by the cell, right? But we have to take thing into always negative. So the formula of delta G also becomes of negative of work done by cell, which is negative of NF E naught cell. Now you might be worried, what is this N, what is this F, what is everything coming from? So let me tell you, delta G is the change in Gibbs energy for the cell, which is also equals to the free available work done that you can use as a non-mechanical work done. This is the work done by the cell, and this is a charge into potential. So N into F is equals to the charge of N moles of electrons E naught EMF. Which one? Standard EMF of a cell. So using this formula, we can find out the values of delta G, W, whatever it is needed. F is actually charge of 1 mole of electrons, which is also called as 1 Faraday. 1 Faraday. How much is this charge? 1.6 10 to the power minus 19 coulomb multiplied by 6.022 10 to the power 23. This is the charge of 1 mole, and mathematically comes up as 96500 coulomb per mole. Learn down this part and then we'll. Okay, I'll bring the VIEEE preparation strategy also, don't worry. For that I need some time actually. I was not able to manage some time for me and for this strategy and for lecture preparation and everything, but allow me some time. We'll bring it very soon. Okay, now you try the next question from here. Try the next question. Probably a question here. Now this is the question. You better try this by your own. Anyways, let's see the question. The question is pretty simple. For the reaction of silver ion, copper metal, and E naught cell is given to us. Value of delta G has to be calculated out. So E naught cell will be delta G of the cell will be negative of NF E cell. It's a very important formula. You all must know it. That delta G at that particular time of cell will be equals to negative of NF E cell, and in the standard terms, standard exchange in Gibbs energy will become what? This. So negative of how many electrons have been transferred, that you should identify by writing down the electronic complete equation. That silver ions are there, copper has been there, Cu2 plus will be formed, Ag will be there. What you need to do is just balance them in charges. This will become 2, this also becomes 2. This should be a balanced chemical equation, otherwise everything will be incorrect. And then you can find out how many electrons are lost and gained. So we can easily find out that since silver from 0 has reached to positive 1, sorry, from the positive 1 oxidation state reached to 0, or from 0 oxidation state of copper it has reached to 2. So everywhere 2 electrons are basically used in this process. Even if you can write down this like Cu2 positive was there, or like Cu was there, which after reaching to Cu2 positive lost 2 electron, and similarly 2 Ag positive accepted only these 2 electrons, got converted to Ag. So this is how the reaction works. How many electrons are there? 2. Anyways, we'll put this value of N is equals to 2 into 96500 into E naught cell. How much is the E naught cell? 0.46. Now you multiply this whole value and get the answer. It's that simple. Now, what is the relation between E naught cell delta G for these kind of reaction which are given in simultaneous way? Iron is converted to iron plus, iron 2 plus is converted, iron plus is converted to iron 2 plus, or iron 2 plus is converted to Fe3 plus, and then what is the value of direct wall? So you can't add these values. Okay, let me give you an example, and that example will be highly sufficient to understand the concept, which is the intensive nature of E cell and extensive nature of delta G. So guys, first let me reveal this example and then I'll explain how is it incorrect. So we got to find out this value, and what we are given up with these values 1 and 2. So let me simply write Cu2 plus to Cu. So first of all this value. So guys, Cu2 plus was there, then I added with it 1 electron, and we converted to Cu plus, and we also has this value. So what is the value of E naught cell here? E naught 1 is exactly equals to 0.153 volt. Second reaction 2 plus 2 Cu. So 2 plus 2 Cu. Okay, let me reverse this reaction. There are 2 reactions. Let me write the first as it is. So E1 is given to you for the first equation 0.337, and second equation, this Cu 2 plus 1 electron makes you this. So I'll reverse the equation. I'll write Cu positive, and then Cu positive loses 1 electron, forming Cu2 positive, and for this reaction the E2 will be reversed and with a negative of 0.153 volt. So are we understanding what is happening here? Now you add both of these equations. So what will be getting? Cu plus Cu2 plus will be cancelled out. It will be simply become Cu positive plus 1 electron to Cu. So how do you identify its value of E3? So you are just simply adding them. What is the value? 0.337 minus 0.153. And how much the value should come? 4, 8, 1.84, 0.184 volts. But this is incorrect. This is your incorrect approach. First of all, you figure out your mistake. I'm writing simply in the front of you. Just try to find out the mistake. Try to find out what mistake have you committed here. No doubt there is a mistake, but what mistake is there that you need to identify? Okay, now let's see. So this is the incorrect approach. So what should be the correct approach, by the way? What is the mistake that we committed here? We can't add E cell directly. You cannot add E cell directly because E naught cell is an intensive property. It's not an additive property. So what has to be done? Now let's see what we can do. We'll make it an extensive property in terms of gives energy. How? Let's see. So we initial solution. We initially had copper 2 plus with 2 electron converted to copper. Instead of writing its delta, E naught cell, you write delta G1. Delta G can be added. What is the value of delta G1? NFE. N is what? Minus ka 2 into Faraday. How much is the E naught cell given in the question? In question it was 0.337. Positive. This is the energy, okay? In joules. Same thing we'll be doing for the next step, that is Cu2 positive. Cu positive, losing 1 electron, reaching to Cu2 positive. Delta G2 will be number of electrons, negative of 1 electron multiplied by its electrode potential is negative of 1.53, 0.153, sorry. This has become what? Again joules. Now you do one thing, add both of the equations and reach to the final one. So in adding both of them, what will give it to us? It will give us that Cu2 positive on acquiring 1 electron gets converted to copper positive. So what is the value of delta G3 overall? Add both of them. So what does it become? I think it's 2 times of that minus 1 times of this. So 2 times of that. Actually it is equals to the 1 electrode, 1 Faraday into E naught of Cu positive to Cu. So some of them will be coming up as negative of 0.764 Faraday minus का and then plus 0.153 minus का Faraday into E naught of Cu positive to Cu. So Faraday will be cancelled out, isn't it? Faraday will be cancelled out, and the remaining one will be, just solve it. I think this will come in positive only. This is the correct answer. So the incorrect answer was earlier 184. It is incorrect. This is the correct one, and that's how we have to approach while solving these questions. Because you have to consider this part, that whenever we are doing these questions, the additive part that can be added is Gibbs energy or change in Gibbs energy. What we cannot add is your electromotive force or EMF. So that's the motive of this reaction. Now we'll solve some question and we'll figure out. We have the standard Gibbs energy for the given reaction in kilojoule per mole. So it's very simple. I don't think it's needed. Do one thing. Delta G is equals to how many electrons are forward? 2. Faraday is 96500. E naught cell is how much? 1.1 electron volt, I guess. Sorry, 2 volt is given. So just solve it. Minus ka 4 times of 96500. So that's how it will come. Nearly here. Negative of this joule. This is another question, and a similar kind of question was also paid in 2025. We are not sure about the question exactly, that's why I didn't pick the question for here. But meanwhile, right after 1 or 2 days, you will be getting your final answer keys as well, questions also, and you can challenge your answer key as well for JEE Main 2025, and then you will realize how the questions were asked on this concept, how we have to respond them back. So there is one question. First of all, I would expect you people to try this by your own, and then I'll take you to the next concept from here. So what is this question? E naught cell in voltage for so many equations given to here. First of all, for this, what we can write it simply, E naught of this cell finally is equals to cathode minus anode. So cathode is what? Ag minus what is anode? Iron 2 plus 2 3 plus. No, iron 3 plus 2 2 plus only we have to write, because we are now taking in cathode minus anode like that. This value is already given to us x. Minus we have to find out E naught for Fe3 plus 2, Fe2 plus. So this is something what we have to first of all identify. How? Using this given data. So the product is 2 positive and this is 3 positive. So I'll do one thing. I'll write it in reverse. So how am I going to write it? That Fe becomes Fe2 plus by losing 2 electrons. This is your delta G is equals to negative of 2 Faraday into E naught cell is actually minus Y. Another equation, Fe from plus 3 accepts 3 electron forming simply Fe, and for this delta G has been given to us negative of electrons are 3 Faraday into electrode potential is simply Z. On adding both of them, you will be getting Fe3 plus 1 electron gets Fe2 positive. Rest everything will be cancelled out. Delta G will be equals to what? Minus ka Faraday 1 into Faraday into E naught of, that is what we have to find out. 3 plus 2 2 plus Getting me? How am I reaching there? 3 plus 2 plus. What will be equals to sum of these two? What is this, by the way? This is your positive 2f and this is 3f. So negative of f3z minus 2y. So that's how you'll be getting it out. And the value becomes what? This is what? EAF E naught for Fe3 plus 2 Fe2 plus will be 3z minus 2y. So use this equation over here and then you'll be getting your answer as E naught of the cell is equals to what? X minus this value, x positive 2y minus 3z. X plus 2y minus 3z. C. Got it, guys? Very easy one. There is another question came in JEE Main 2025 this year itself, and the question is a bit different, but I think you can solve it. The concept that we have already covered is in the question, that the standard electrode potential for a half cell are mentioned below. Standard electrode potential for a half cell are given below. So which of the following cell will give you the most negative value for delta G? So you know what's the meaning of delta G? Delta G is equals to negative of NF E naught cell, right? And probably all of them are having the, so anyways, that first of all N should be maximum for most negative. In order to make it most negative, there should be maximum. And what about the E naught cell? E naught cell should also be what? Maximum. Then only the most negative value will come up. So you can find out using all of them, and no need to do the calculation as such. You can simply think of the everything in your mind itself. Mostly of them are 2 positive, positive, 2 positive, and zinc, magnesium, copper, silver, and they see N is same. N is actually maximum. It can come up as 2, not beyond that. Only E naught cell can be changed, but I think the correct answer should be for most negative value of this. I think the correct combination should be zinc and silver. Zinc and silver, the E naught cell is actually coming up as what? It is silver minus zinc, cathode minus anode. Silver minus zinc is what? Everything's reduction potentials are given, no need to worry. 0.80 minus, this is also given in negative. So 0.8 minus 0.76. So this will become what? 1.56 volt positive. So that's what you can do. Okay, I think C is the correct answer, and you can check for the rest one of them. All of them are under standard only, standard conditions. There we go with the next topic of the day, everyone. The next topic of the day is Nernst equation. Again, an important fundamental parameter to find out the. So till now we know that E naught cell can be calculated as this is also SRP and this is also SRP. But how to find E cell? How to find E cell? Using E naught cell value. So there's a very simple formula that we can use. So write in 11th standard, from thermodynamics we study one equation. From thermodynamics we studied this equation. What was the equation? Delta G is equals to delta G naught plus RT ln Q. Q is any reaction quotient for a reaction. So now if we convert, delta G is equals to negative NF E cell and delta G naught is equals to negative NF E naught cell. Using this data, how can we identify the values? So delta G is what? Negative NF E cell is equals to negative NF E naught cell plus RT ln Q. Dividing everything by negative of NF will become E cell is equals to E naught cell minus RT by NF ln Q. On solving, this becomes E cell is equals to E naught cell minus 2.303 RT by NF logarithm of reaction quotient Q. And again, very important part, everybody. So at the rate standard condition, temperature is 25 degrees Celsius, take it to 98 Kelvin. Pressure will become 1 bar. R we all know. What else is there? Faraday, charge of 1 mole of electron, 96500 Coulomb per mole. And I think rest everything is there. You can solve it. You can find out the value. E cell is equals to E naught cell minus 0.059, which you can also written as 0.06 by number of electron transferred, logarithm of reaction quotient Q. Remember this formula. It's a very important formula going to be used a long time in our upcoming class. So please visit this formula and try to learn out formula ASAP right now itself. हजारों में कहूँगी दीवानी तू मेरी, मैं तेरा पागल पिया। So guys, now I'll take you to the application part of this equation, and there it comes. So you all know the value of Q is pretty simple to identify at any kind of condition, and this kind of reaction quotient have to be used in terms of Ions, we got to take their molarity as a concentration. For gases, we'll be taking their activity as pressure in bar. For all solids and pure liquids, they'll be taken as 1. Rest everything we know, just we need to apply the formula and we'll getting the answer. What does it depend upon? Nature of electrode, because E0 value may change for different electrode. Temperature was very much required there at 25 degrees Celsius, we assumed it, and using that we found out the value of 0.06 by NF. Concentration is needed and pressure is needed. So now let me take you directly to one question. Okay, sorry, my bad. For this question, which is very important and very easy also, the value of Q was asked. Q can be written down in terms of aqueous solution, product upon reactant. Product, if it's stoichiometry is given to you, you got to write it. If not, then simply move forward. Water cannot be reactant because this is a liquid, and permanganate ion also has an aqueous state. Its concentration has to be written down. H plus is also an ion in aqueous state. Its concentration to be written down. Along with its stoichiometry goes in power. Electron is no physical state. We don't need to write down anything. Q is written down like this. So what will be the value of E cell? E cell will become equals to the E0 cell minus 0.059 by number of electron transferred is 5, already written down over here. Logarithm of this value of concentration of Mn2 positive divided by the concentration of permanganate ion into concentration is positive raised to power 8. Follow it and you will get your answer. Which is the correct answer, by the way? I think this is the only correct answer. So one more question is here. Value of E0 cell is already given to you. Potential at pH equals to 2. At pH equals to 2, what will happening? Concentration H plus becomes equals to negative of 10 to the power minus 2 molar. 10 to the power minus 2 molar only. So how is to be applied? So E cell will be equals to E0 cell will be 1.33 minus 0.059 can also be written as 6, and even if you want to go for 59, it's also fine. So 0.59 by number of electrons are how many? Transfer number of electrons can be identified using this equation, 6 electrons. Rest you also can find out. Okay. We can also find it out using 6. This is from 6 state going to 3 plus. Number of electron change is 3 for 1 chromium. 6 will be for 2 chromium atoms. Like that also you can find, but not required. It's already given here. Logarithm of product side, we have concentration of Cr2 positive raised to power 3 divided by concentration of dichromate ion Cr2O7 2 minus raised to their power of stoichiometry 1 and H positive raised to the power 14. So I guess this is given to you 1 molar. This is also given to you 1 molar. No required. This is actually 1.33 minus. This will become, this can be taken as 0.06 roughly. So this will become 0.01 and logarithm of. So this is 10 to the power minus 2 raised to the power 14, 10 to the power minus 28. It will become positive 28. 1.33 minus. So this is actually logarithm of 10 to the power 28 is 28. 28 into 0.0 will be 0.28. Now solve this and you will get your answer. I think 1.05 volts is the correct answer, and that too in positive. Correct answer should be D. D is the correct answer. Right, guys? Another question is here that you must try by your own. Try to write down all the equations using the same thing, that E cell is equals to E0 cell. The E0 cell is a constant now. This has become constant for all the given cells. Minus 0.059 by NF. NF is also same. N factor, or the number of electron transfer, which is 2. Logarithm of. So right hand side, what do we have? Zinc and copper are basically combined. Zinc is the going to oxidize, so that N2 plus divided by Cu2 plus. That's the equation that you have to use. Simple like that. So just need to get the this ratio only, and this should be what lesser, so that you'll be getting E cell as higher. Try it and then solve it. One more question. Considering a reaction at 298 Kelvin, chromine and bromine ion are reacting. Reaction is going like this. Something is given like this. And 180, everything is given to us, and what's been asked here? I think everything is given to us. So E cell will be equals to E0 cell 0.29 minus 0.06 divided by number of electron transferred is how many? 2. How can you identify it? 2 bromide ion going to Br2. So 0, it is -1 to 0, 1 change, and 2 bromine will bring 2 change. And similarly Cl2 0 to going to -1, change of 1, and twice of that will make you change of 2. Logarithm of what has to be used, right? Concentration of Br2 first of all, because it is given in aqueous, not liquid, and then Cl minus raised to the power 2 divided by Cl2, partial pressure of Cl2, then bromide ion concentration raised to power 2. But I think bromide ion and chloride ion the same, they will be cut down over here. Concentration of bromine, so this has been given to you 1 atm, and bromine concentration is given to you 10 to the power -1, -2 molar. These are two are cancelled out. So anyways, this becomes 0.0, so 0.29 minus 0.03 into concentration is 10 to the power -2, that upon multiplication with logarithm 10 to the power -2, 10 to the power logarithm 10 to the power -2 is -2. So this will be actually added down. I guess it will be added down as 6. 0.35 volt is the correct answer, and that too in positive. So I think B should be the correct answer. Check out B is correct. Then move forward. Take this question as a homework. Try it by your own. Make yourself ready. And then comes the equilibrium constant. So what is the equilibrium constant? For this also I have a very secret thing to tell you, and very fastly you can do the calculation. So what happens in these terms? First of all, at the rate equilibrium, you must know whenever the equilibrium comes, delta G becomes equals to 0. Change in state function becomes what? 0. So if delta G 0, then the negative of NF E cell must also be equals to 0, providing you E cell will also be equals to 0, because number of electron cannot be 0. So using this formula, what I can identify that E cell was earlier equals to E naught cell minus 0.059 by N logarithm of Q. Then at the rate equilibrium, suddenly Q has converted to K equilibrium, and E cell has been converted to 0. So E naught cell will become equal to 0.06 upon, or 0.59 let it be, upon number of N electron transfer logarithm of K equilibrium. That's the formula we have to use. Isn't it very easy? Yes sir, it's very easy to those people who have already studied the Nernst equation. It's an easy formula to all of them. Now I'll take you to the question and the application part. At chemical equilibrium, delta G of the reaction in E cell becomes 0. Yes, true. But delta G naught doesn't become 0, because delta G naught is a condition that has been taken from the standard point. So there is a possibility that at standard condition equilibrium might have not covered, might have not come. But at equilibrium, the current condition says us about the E cell, that should be 0. And then E naught cell can be calculated out using that value. So anyways, there is another question that E equals to E naught minus RTNF, and Q indicates that Q will be equals to the equilibrium constant K. If Q is equals to K equilibrium, then E cell should be 0, then E equals to 0. Then we also have, since E naught cell is equals to 0.059 by N logarithm of Kc, K equilibrium. So the graph between this is actually what? This is your y is equals to mx. It's a straight line graph. A should be the correct answer. Another question from JEE Main 2022. The question appeared in JEE Main 2022. Please try to solve this question along with me. The pH of acidic solution was found to be 3. Where is the concentration of CO2 positive is this? What is the value of X here? So we'll try to do one thing first of all. Try to identify the value first of all. So this value, cell potential, is given to us 0.31. Okay, so E naught cell first of all we have to find out. So E naught of this cell will be equals to E naught of cathode minus anode. What is cathode? Cathode is copper. Minus anode. What is anode? H plus 2H2. But this has to be taken as 0 only. As you all know, it's a reference electrode. We always take it as 0. This value will become what? 0.31 volt. which is your E naught cell, equals to E naught of copper 2 plus 2 copper. After knowing this value, what we can identify is cell potential at pH equals to 3. So cell potential E cell will be equals to E naught cell minus 0.059, or you can take it 0.06, it has been mentioned here, upon number of electron transferred is 2 logarithm of, okay, the cell reaction we have to write it first of very all. Reaction will become what? Copper 2 plus H2. One of them will acquire, one of them will lose. 2H plus copper. Look at this. This is the equation that what we have to use. So now logarithm of what? H plus concentration will be raised by power 2. For acidic condition, the pH is found to be 3. That means concentration of H plus in the solution is equal to 10 to the power minus 3 molar. As simple as that. So 10 to the power minus 2 raised to power whole 2. Copper is solid, no need to write it down. This is aqueous that you need to take. This is gaseous you need to take. This is aqueous you need to take, and this is solid, no need to take. No need to take solid and pure liquid. Aqueous we have to consider. Reactant side we have copper 2 plus ion. What is the concentration of copper 2 plus ion? Is 10 to the power minus x, that is 10 to the power minus x, and raised to the power 1. And what is the partial pressure of hydrogen? Hydrogen is 1 bar, so it's simple that 1 bar only, like that. So anyways, this is something that we have to basically find out. This value has come up as 0.31 given in the question. This is negative of 0.03 is equals to negative of 0.03 logarithm of 10 to the power minus 3 minus 6 upon 10 to the power minus x. So guys, can you identify that this is actually equals to 1? So logarithm of something equals to 1. So logarithm of this is what? 10 to the power x minus 6 is equals to what? 10, because this is value equals to 1. One is log 10. So then x minus 6 will be equals to what? 1. X minus 6 is equals to what? 1. So x comes up as 7, I guess. Can I check it again? X minus 6 value was actually 10. I think 7 is correct. Okay, see, 7 is correct answer. We have few more questions. Our practicing question, doubt session, practice session and doubt session will be conducted tomorrow. Tomorrow morning itself, 10 o'clock. Link has already been given in the description. Please go there and notify for the class, enroll in the class by following some of the very basic formalities. Then we have another question, a cell involving one electron, and that's how the reaction is going on. What is the equilibrium constant? It's an easy question, and let me do it. So we'll apply the formula that E naught cell is equals to 0.059 by number of electrons are how many? How many electrons have been taken as okay, 1, it is also saying 1, and then it equals to logarithm of equilibrium constant. So E naught cell is also equals to 0.59. So this is 10 actually. 10 is equals to 10 to the power 10 is the correct answer. I think this is correct. So you try the questions by your own, and I think you will become very confident. Then another similar question is here. If the standard electrode potential is 2 volt at this, at 300 Kelvin this will be what? Anyways, another easy question. So what you need to do is simply apply the formula that E is equals to if the standard liquid potential of 2 volt as 200 Kelvin, the equilibrium constant of the reaction. Okay, equilibrium constant is to find out. So simply say that E naught cell is equals to 0.059 by N Okay, I think we cannot use this part because this has been asked in ln. So E naught cell will be equals to 0 and 0, okay, RT by NF. So this is your RT by NF and then ln of K, like that you do. R is given to you 8, temperature is 300, number of electron transferred is standard electrode potential. For this, okay, 2 electrons have been transferred here. 96500, 96,000 has been given to us, this value, and then it becomes ln of K. This is also given to you 2 volts. So 4 into 96,000 upon 8 into 300 is equals to ln K. Just find out this value and you will get your answer. This is 2. $1,600 or 60? I think 60. If ln K is equals to 160, e to the power 160 will be your answer. C. So that's it, everyone. That was up to. So where did we reach in this chapter? It's a huge chapter. It's a big chapter, by the way. And till here we have covered a bit important part of this chapter, which is your Nernst equation, EMF, calculation, electrochemical series, reduction potential, oxidation potentials, electrode potentials, and then also one more part was covered is that is calculation of E cell at random temperatures, random conditions, that is called as E cell using Nernst equation. Then we have metal insoluble salt and ion, half cell electrode, and from here we'll start in just small break, but do few things that I want to mention it here. So right now we are having a small break and do one thing. There is a session which we have you got to enroll for special session where we will be having doubts plus practice, and for this the link is in description. The link is given in the description itself, and also stay tuned, and those who haven't liked us, like this session. की कहानी ऐसे मोड़ पे चलिए, hopefully. So guys, where were you? Now I've come back and please join the session. Let me see, where were we? There we were. We just have finished a very important part of this session, a very important part of this chapter. What is your galvanic cell, EMF of the cell, E cell, E naught cell, delta G, reduction potentials, so many things till here. Now we have one more type of electrode for us called as metal insoluble salt anion electrode. So it's an important part of our chapter because question may come from this segment also. Look at this electrode. This is how it look like. This electrode is made up of a metal rod which is like I must say which is dipped and like covered with some salt of it, metal salt itself, which is a precipitate AgCl solid, which is a sparingly soluble salt, not a completely soluble salt, and that is what makes this electrode very special. We also call these kind of electrode written over here as secondary reference electrodes. Secondary reference electrode. Why do we call it secondary reference electrode? First of all, with a slight increase or decrease in their concentration, the EMF doesn't vary a lot, because as I told you, it's a like everything happens there, and the ions over there, they all exist in an equilibrium there. And the another point is, using the value of E naught cell there, we also can find the E naught cell value of a particular electrode. So how, that I'll let you know in the formula, mathematical formula itself. So again, let me just star mark this portion, that they all are called as secondary reference electrode, and primary reference electrode was our SHE, standard hydrogen electrode. Now, what reactions basically happen here? What kind of reactions happen here? And how are they represented? They are represented like, so let's say if this electrode is working as cathode, you all know the reaction at cathode. What happens at cathode? We also represent it like E naught. What reaction will be there? Reduction is going to happen. Reduction as in, there is AgCl, which is solid, accepting an electron, getting converted to Ag, solid, along with Cl negative aqueous, which is also present in KCl form there. They all are in equilibrium, solid, liquid, everything is in equilibrium there. How to represent it? The cell is represented like AgCl converted to Cl negative. So we'll write it like AgCl being converted to Cl negative. Like that, and I forgot it. Cl minus AgCl to Ag. Okay, my bad. AgCl to Ag. So this AgCl is converted, Ag positive one is converted to Ag, and with extremely left and extremely right, we got to mention this Cl negative. Okay, this is reduction. So Cl at the end, there we are using it, Cl negative. Extremely left or extremely right. Another example could be same electrode as anode. We know what happens at anode. Oxidation happens at anode. What was this? Reduction. Let's see how oxidation occurs. So this will be written down as E naught, where Ag now will be moving to AgCl, and AgCl and Cl minus are always written down closely with each other like this. Then the reaction will become what? Silver getting reacted with chloride ion, aqueous solid, forms AgCl plus an electron. So this electron lost is actually a part of oxidation. This process is oxidation. That is what completely reaction works alike. And now I'll also let you know how do you find out the value of E cell using this formulation, using this of particular this cell E naught. So let's see how do you find out. How do we find out? Okay, so we know that AgCl is in equilibrium with Ag positive and Cl negative, right? This is solid, aqueous and aqueous. For this reaction, guys, we can write down delta G naught is equals to, how do you write the delta G1? RT ln Q, right, isn't it? RT ln Q. We do not know the E cell for this reaction, so we will write it in the terms of, and the K equilibrium is called as KSP. So what does it become? R into T. Delta G was equals to delta G naught plus, so delta G is equal to minus RT by NF, not by NF, simply RT ln Q, or at equilibrium it will become what? KSP. Another equation could be, another reaction is that Ag plus Cl negative gives us AgCl plus electron. And what about this reaction? We can also write this reaction as delta G naught 2 is equals to negative of NF, N is 1, Faraday, E naught cell, E naught of cell. So what E naught cell, what we have to write out? This is an oxidation potential, as I can see, and I can write down this equation as Ag is going to AgCl, and this is where we have to write down the Cl negative. Okay, extreme right, extreme left, like that. If we add both of the reaction, AgCl will cut down. Simply the reaction becomes Ag. Cl minus will also be reduced down. This reaction is what? Ag plus, sorry, Ag simply going to Ag plus plus electron. So this is a simple reaction what we can see, right? Isn't it? Yes, sir, of course it is, which can also be written down as delta G3 is equals to negative of Faraday, negative 1 Faraday, and E naught of what we have to use is Ag to Ag positive. It's that simple, isn't it, guys? That reaction potential we have to take Ag to Ag positive. So after solving these two, if we make this thing done, okay, I'll simply explain it to you. If you can write delta G3 is equals to delta G1 plus delta G2. If you can simply do this, delta G3 is equals to delta G1 plus delta G2, what you'll be observing, your final formula, and that is a general formula for all the metals, metal soluble salt, anion electrode. So the general formula comes up as, the general formula that E naught Ag positive going to AgCl and then Ag. What is this, by the way? SRP will be equals to E naught of Ag positive to Ag, which is another SRP, minus 0.059 by whatever the number of electron is there, logarithm of Ksp. Remember this formula, very important one. It's a very important formula, by the way. And I'm also cross checking it. It is okay, it's plus actually. So AgCl to Ag we are reaching, and this is the Cl minus. AgCl is nowhere. So that is how it is written. Okay, this is Rp, this is Rp, and there's a plus sign while we are mentioning it. It's a plus sign. Similarly, the same reaction can also be written down as and the value of n can be assigned wherever it is there. That's how we do. Okay. So another example is calomel electrode, everyone. This is called as calomel electrode, where we are having a salt called as mercurous chloride Hg2Cl2, or Hg positive is there. So let's say if you have to find out the value for this also, so again we'll be having the same formula. So this salt is called as Hg2Cl2, which is in equilibrium with, which will, on equilibrium will give you 2Hg positive plus 2Cl negative. Let's say we are given with Ksp value. So how do you identify the value of E naught Cl negative Hg to Cl2 to Hg? Reduction is happening, right? This is SRP. So how you identify it? E naught of Hg plus 2Hg. Again, this is SRP plus RT by NF, and that value is also equals to 0.06 by N, 0.059 or N, and then comes logarithm of Ksp. Again, Ksp of Hg2Cl2. So that's how we have to use it. Just generalize this equation and then we can use this equation. Okay. Just generalize this formula and then use it. हाँ 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 ठीक. हो लाई रे लाई जिंदगानी की कहानी ऐसे मोड़ पे हुए रे हम यूं पराए खुद किसी से नैना जोड़ के. So a question is here, which of them can be reused as a secondary reference electrode? So all of them will be coming as an answer, because all of them are metal insoluble salt anion electrode, and in fact these two are the same only, written down over here, calomel. Then one more question is here. Ksp of this, pKsp means negative logarithm of Ksp is given to us 16. So KSP will be what? -16. And if the E naught value for Ag positive and Ag is 0.8 volt, then find the E naught cell for the half reaction of. So E naught for Ag positive to Ag will be what? Not that, yaar. AgCl to Ag, and this is always kept with Cl negative, will be equals to what? E naught of this 0.8 plus RT by Ns 0.06 by number of electron is 1, and logarithm of KSP. What? How much is KSP? 10 to the power minus 16. So how much does it come? 0.8. I think this will go in negative. Negative 16 into this. 16 के 96 0.0 16 96. I think negative of 0.16 volt should be your answer. So that's how you have to apply. So that was your one of the very important part of this cell called as metal insoluble salt and anion electrode, and just don't go in very deep, otherwise you will be getting confused. The value, how do you find out, is been already told to you, the derivation part of delta G and using those individual equation applying in the final one. But most importantly, the formula direct should be remembered. That is RP of E naught of AgCl to Ag is equals to E naught of Ag to Ag plus RT by NF logarithm of KSP. That's the formula that we use. There comes the concentration cell, the final part of galvanic cell. Concentration cell. What is a concentration cell? In which both electrodes are made up of, like cathode and anode, both of them are made up of same material. Hydrogen electrode. But difference is there in either in the terms of their pressures, either in the terms of their concentration. So now we have two type of concentration cells. One of them is called as electrode concentration cell, another one is called as electrolyte concentration cell. Electrode concentration cell is there where gaseous electrode has different pressures, like one of them is having pressure P1, another one says P2. And concentration electrode cell, electrolyte concentration cell will be those in which concentrations are different in both of the compartment. Anyways, it's an easy concept, and we can know that E naught cell will over here will be 0. E naught cell will be 0, but E cell is not equals to 0. Let's take an example. So let's take an example. Both of them we can see zinc is there. So at the rate anode, what happens? Tell me. So once we'll be knowing about the overall reaction, then only we can apply the Nernst equation. So anode is this. Basically, this is anode. And this is happening in cathode. So at the rate anode, zinc is being oxidized. So how much is the concentration? Let's say C2. And what about the cathode? Reduction will be happening. Same reaction with Zn2 plus. यार क्या बना दिए हो भैया? Zn2 plus 2 electron goes to Zn, and there we have C1 concentration. It has been shown. Left hand side anode, right hand side cathode. No, not like that. This is C1 only. This is C2. There is C2. This is C1 molar. How? Because in same compartment is happening. Same compartment zinc Zn2 plus. Same compartment Zn2 plus Zn. So that's how the reaction is working. So if I see the overall reaction, it's only ion to ion in exchange. So Zn2 plus is to Zn2 plus. So this is your cathode, which is C2. This is your C1. Am I right? Yes, absolutely. So what is the Nernst equation? So E cell, E of the cell will become what? E naught is 0 minus 0.059. So 0.059 by number of electrons n negative logarithm of C1 by C2. So for feasible process, E cell should be what? Positive. In order to make this thing as positive, this should come as less than 1, so that it will become negative and overall it will become positive. So C2 should be greater than C1. Look at this condition. C2 should be greater than C1. The concentration in reduction side, cathode side should be more than anode side. Next is electrode concentration cell. Electrode concentration cell mean we are now introducing different pressures there. So let's say the electrolyte has been taken in the same concentration, which is H positive. Look at this H positive. So this is your anode side, left hand side, and this one is the right hand side, which is your cathode. What happens at anode? Oxidation. So at the rate anode, what will happen? H2 will be oxidized to, and let's say this pressure is P1, 2H positive plus 2 electron. At the rate cathode, what will happen? Reduction. Reduction is what? H plus, but the concentration might be the same, C1, but this is now converting to H2, and this gaseous has, let's say, P2 pressure, P1 and P2. So overall reaction is H2 from P1 to P2, H2 gas to H2 gas, rest all will be constant, and that too from P1 to P2, left hand side P1, right hand side P2. That's simple. So E cell will be, E naught cell is 0 minus 0.059 by number of electron, let it be 2, logarithm of partial pressure of this, partial pressure of that. This will become what? Partial pressure of P2 by P1. Now in order to make this thing as positive, we got to take this thing as negative. This negative into negative will become positive, but making it negative, P2 by P should be less than 1. So P1 should be greater than P2. Now check out the relation. There C2 was greater than C1. Here P1 is greater than P2, and that's how we do it. So I guess that's it, guys. Let's not stretch this topic too much. We have plenty of things to cover in this chapter. So let's say a question is given: zinc is going to Zn2 plus from C1 concentration to C2 concentration. Now the cell delta G should be negative. Delta G is negative. So E cell becomes what? Positive. And if E cell is positive, you know what is the, you can also write the overall equation, okay? Don't get confused. Overall reaction is what? This is going there. So Zn2 plus from C2 goes to Zn2 plus in C1. Basically this goes from anode and this is from cathode. You remember? So your E cell will be 0 minus 0.059 by n and logarithm of C1 by C2. So in order to make E cell as positive, C2 should be greater than C1. C2 should be greater than C1. C option is there. And that's how we do it, okay? And remaining number of questions, I would like to expect you people to solve them, okay? And this question can be seen in my upcoming solving session also, doubt solving session and practicing part that is conducted tomorrow. Tomorrow 10 AM all of you have to come to our Unacademy application. The link is given in the description. It's all absolutely free. You don't need anything to pay there. Just come there, enjoy the doubt solving session, ask me all the doubt you have academically, non-academically, from electrochemistry, for anywhere you want. But make sure you come. And also we'll also have the practicing part. So top 50 question will be given to you, mains and advanced, and these kind of concepts will be typically asking in these some years of the mains and advanced I've seen. So that will be done, okay? This is another question you can do. Then we have one more question that you should solve by your own. And now we'll directly come to the, let's say, a question from advanced we got. Thermodynamics of galvanic cell. Actually, thermodynamics of galvanic cell is a bit typical topic. Change in gives energy, so we already know that negative of NF E naught cell. So it's very simple. Even delta G can also be identified at any kind of temperature or pressure. Right? You remember it? The formula was delta G is equals to negative of NF E cell. But what about delta S? So I'll give you the idea how are they derived, but I will also write how is it calculated. This is NF del of delta G by del of delta G by delta T dt, and that is done under constant pressure. This is the formula that you have to learn. Okay, if we can learn it directly as of now, then I'll give you its explanation also. Always remember, this is called as this delta G by dt at constant pressure is called as temperature gradient. At constant pressure. You also remember this part, delta H. What is delta H? Delta G plus T delta S. Do you remember? So simply put it, minus NF E naught cell plus temperature NF del delta E del delta G by dt. So like that you have to apply the formula, and then it becomes finally what? Delta H is equals to what? Let's take minus NF as common. E naught cell minus temperature delta G by delta T. That's we can do. But again, these calculations are done at constant pressure. So these three formula we have to take care in our mind. If we don't remember the third formula, it's fine, because both of them can derive to the third. Okay, both of the above formula can give you the third formula by using the equation delta H equals to delta G minus delta G plus T delta S, or delta G is equals to delta H minus T delta S. Using that you can find out it. Let me take you directly to one question. There's a question that you should do by your own, and I'll give you the way how you reached it. Temperature coefficient which we have given to us, delta E by delta T. Basically this E is your change in Gibbs energy, and this portion is given to you 1.5 10 to the power this joule Kelvin inverse. Temperature is also given to us. Change in entropy during the cell is. So what is the formula of change of entropy? Delta S naught is equals to NF del E by del T. Del E by del T at constant pressure, as I told you. So this E is actually equals to delta G, and this comes always in positive. Now put the formula, get the answer. Is kind of thing is being asked. So n number of electron transferred here is something from 0 is going to positive 2. It's 2 only, and this is from positive 2 to going to 0. So this is 2 multiplied by 96500 Faraday into temperature gradient. That is how much? 1.5 10 to the power minus 4. So 1.5 into 2 is 3. So it's 3 into 9.65 is the correct answer. Can you identify this value? .895. What's wrong, man? जाना समझाना दिल कहता है. Okay, like that you have to do. A. This is also Kelvin inverse, so the joule Kelvin. So another simple question is there that I would like to expect you people to do it by your own homework. Then next comes is electrolysis part. Okay, right after finishing our galvanic cell, which we started from, We also took an idea of galvanic cell to electrolytic cell, but we didn't do it very in depth. And there is one more theory that works over here. That theory is called as preferential discharge theory, very important part of this segment. So anyways, molten NaCl is pretty easy. See, what is molten NaCl? So molten NaCl gives you two parts. One of them is Na positive and the another one is Cl negative, and we will write it simple liquid. So what happens at the rate anode? But you know what is the charge on anode? It is positive charge. It will attract negatively charged particles. Let's say 2 Cl negative are coming, and it forms Cl2 plus 2 electron. This is actually oxidation happening here. Then what happens at the rate cathode? Two Na positive ions will accept these 2 electrons and will be converted into Na, right? Solid, gas evolved. Okay, this is called as deposited. So that's the overall reaction you can see. So if I combine both of the reaction, this is NaCl liquid converted after electrolysis to sodium metal to chlorine gas. So this reaction, what you see in front of you, is actually a non-spontaneous reaction. It doesn't happen by itself. That's why it required continuous support of electricity. For these reactions, delta G is positive. Cell reaction, delta G is positive. I am continuously reading your chat also. So wherever you stuck, wherever you want to find any doubt or you want to find any solution, do let me know. Else, please move forward. Molten PbR2, the same behavior will do. We have no problem as such. We had lead 2 positive, which will acquire 2 electron, will be converted into lead solid, which is deposited. And one more thing we must know, that this is happening at the rate cathode, because cathode is a negatively charged plate. The process happening is reduction. What you observe, the same thing at anode, which is a positively charged plate attracts the negatively charged particles. Negatively charged particles are 2 bromide ions accepting, not accepting, producing 2 Br minus, and Br2 liquid is deposited. 2 electrons. This process is oxidation. Overall, what is it? Electrolysis. Okay, what we are doing is electrolysis. What does it make? Lead solid, Br2 liquid. Check it out. But this is true up to when we don't have any counter ions. Counter ion is in competitive ions. Let's say in the same solution we have chloride, bromide, iodide, then who will go? Then applies the preferential discharge theory. It's very simple. Don't worry, don't panic. But before that, let's solve one question. In electrolyte is a flow of electron. So I told you at the start of the explanation of this concept of electrolytic cell, that in electrolytic cell, one of the electrode, both of the electrode are dipped in the same medium, same aqueous solution, let's say, and the electrolysis is carrying on, electricity is provided. One of them is losing the electron. The same medium is there to help to reach the electron towards the cathode. From anode to cathode, the electron will transfer. So this is how it works. So basically this is happening. Flow of electrons takes flow from internal supply from cathode to anode should be the correct answer. So just learn it, man. From cathode to anode it is going, right? So cathode actually was doing what? Reduction was happening there. How come is it accepting the electron here? So guys, remember this actually amazing part. You can learn it down. And now what if I ask the same thing for a galvanic cell? For a galvanic cell, what happens in the case of a galvanic cell? So in galvanic cell, the same thing happens like this, that electrons flow from anode to cathode via external wire or external circuit. Just opposite. Nice, yaar. No, it will take time actually. Fine. Right. Chalo guys, now let's see. So let's see the another question. Delta G naught for electrolytic cell. Electrolytic cell we see the reactions in electrolytic cells are non-spontaneous reactions. For all the non-spontaneous reactions, the delta G will be what? Positive. Which of the following statement is correct? Process is spontaneous, no. Delta G is negative, no. Delta G is 0, no. Process is non-spontaneous, this is correct. Electrolytic cell, the process is non-spontaneous. Okay. So guys, let's see, these are some basic questions we do. But if I give an idea, let's say we are taking now aqueous NaCl. So if we are taking an aqueous NaCl, so there will be like two things that will be coming. One is NaCl aqueous. On electrolysis it produces Na positive plus Cl negative. This is aqueous. This is aqueous. There is one more thing that we face here is water. However, water also remains in the ionic form like this, but not too much concentration. This is like in not so much concentration, and we know around 10 to the power minus 7 molar, which is very lesser. But I'll give you a shortcut. First of all, let us know how does it work. So now it's a competition. So at the rate anode, what was anode? Anode is a positively charged plate. We have two contender to come, either water or Cl negative. So out of which Cl negative wins. 2 Cl negative produces Cl2 plus 2 electron. Gaseous, aqueous. Okay. But now we talk about the cathode. What happens at cathode, which is a negatively charged plate? So at cathode, there is a competition between Cl negative, Na positive, and water. So here Cl negative goes, and then out of these two, water goes first to Na positive, because water has what? Lesser reduction potential than Na positive, or we can say in opposite way that sodium positive, by accepting electron and converting into Na, this reduction potential is actually very less. In fact, it is in negative. So we'll send at the cathode to water there, and the reaction is pretty simple, everyone. Water can act as both oxidizing and reducing agent. So H2O will be converted into, this is a reduction. See, this is how you have to take thing in the mind. Water has -2 oxidation state. Reduction has to occur over there. No, reduction will be taking place. So this +1 should be converted to H2. H2 gas plus, in order to balance it, I'll put there OH negative. Put some more electrons here. H2O will be there, H2 is there, plus how many electrons were lost there? 2. So it will accept 2 electrons. So it accepts the same 2 electrons. Itself gets converted to H2 plus, to balance it, I'll put some OH negative ions. Okay, OH negative ions. The 2 OH, this will become 4. It will become 2H2O. So 2H2O gains 2 electron to give 2 OH negative to H2. This is a balanced chemical equation. Okay, check out. So this is how the interferences of ion take place. Chloride also had the competition with H2O. Na positive also had the competition with H2O, but out of which H2O won in terms of cathode and Cl minus won in terms of anode. So overall reaction, this happens, and remaining part is, what is remained in the equation? Some OH negative ions formed and some Na positive ion remaining in the equation. So the solution becomes basic. So remaining ions are, somewhere we produced OH negative ions plus Na positive ions. So this is basically NaOH aqueous. So solution is basic solution. So anyways, this is one of the way, and I would like to give you one more way to express the same thing and to complete the same reaction in Mr. David Vila, what's your problem, man? What do you want to understand? Are you not getting the concept I'm trying to understand, or are you that dumb that you don't understand anything? So if there any problem, do let me know very clearly, rather than pointing out your teacher that you don't know this concept. Your teacher has cracked IIT JEE, in fact 15 years back. So don't you raise the finger against your teachers, okay? So respect them. I'll kick you out of this channel unnecessarily if you do the same again, okay? Since I am a very humble guy, I am a very polite guy, I don't interfere in these kind of thing. But don't make your teacher unnecessarily angry, okay? Focus on the content which has been provided, guys. Just practice by your own, yeah. It's a free channel. Everybody is free to study over here, okay? You're not paying anything extra that you can raise a finger against your teacher. I'll block you from whatever the channel is there of Unacademy, and I'll make you suffer. I'll seriously say that, okay? So don't you just ping. Let me not take the thing seriously, guys. But again, I won't allow this part, okay? Now I'll give you a shortcut for finding out the electrolysis product, okay? There's a shortcut, everyone. The shortcut is pretty simple. See, shortcut simply says that NaCl in its aqueous state produces 2 ion, Na positive, Cl negative, aqueous. Water also has in equilibrium two type of ion, H plus, OH negative. The competition is between these four, not these four, two cation and two anion. Out of these two, hydrogen wins. After these two, chloride wins. These two will be remaining in the solution. This will be remaining solution. What is it? Aqueous, NaOH. pH of the solution will be less than, greater than 7 because it's a basic solution. pH will be greater than 7. So you can check out the reactions at the anode. What will happen? If somebody asks you what gas will be released at the anode, so anode Cl negative, 2 Cl negative will come, produce Cl2 gas plus 2 electrons. And if we talk about the cathode, what happens at the cathode? Reduction. Who will come? H positive dominates over Na positive. Why? H positive has higher reduction potential than Na. So H positive, 2H positive will acquire the same 2 electrons. H2 gas will be liberated out. So that's how the reaction occurs. The remaining part will be over there. This is how you can find out these number of values, these reactions, and the product produced on the cathode and anode respectively. So this is where it has been accepted that if there are more than one ion, same type of ion, either cation or anion, then we have to use the preferential discharge theory, right? And guys, so anyways, do allow me for a moment and please have a look. Please learn it right now ASAP. This is the same only. This is something the same only. We studied in the electrochemical series. The reduction potential is increasing, going from potassium to gold, and this is somewhere different. But you see, as many as number of oxygen is there, that will be more. What should I say? Surrounded by water molecule, difficult to movement. But iodide is doing the best. So I minus, Br minus, Cl minus. So like let's say there's a competition between sulfate ion and hydroxide. Hydroxide will win. That will undergo the reactions at anode. Nitrate versus chloride, chloride will win. Bromide versus iodide, iodide will win. This is how we have to work. Just please write down this part, learn it, and then we'll move forward. We'll go a bit fast from here. So now water, I was already talking about that water doesn't have too many number of ions, so water itself goes and gets oxidized or reduced easily. But again we have to check, and their values of water as oxidized and reducing potentials are also given over here. That is RP value for water at anode, that reduction potential is 1.23 volt, and the same value at cathode is negative 0.83. So this is not SRP, this is actually SOP. This value is actually SOP, and SRP is minus 0.83. But anyways, again I'll give you one very beautiful way. One more thing is here everyone, that these two reactions are there for water, and let's say we are doing it for sulfuric acid. This reaction was asked, in JEE Main 2025, where I'll let you know. This reaction was asked in JEE Main 2025, where I'll let you know. So let's say if you want to do the electrolysis of any of the electrolyte given to you, let's say sulfuric acid is been talking about. So do you know what is sulfuric acid? H2SO4, aqueous. Write down in this way, it will give you H plus, HSO4 minus, or you also can call it like 2H plus or sulfate ion. This is the one problem. The another one is water itself electrolyzes itself, giving you H positive and OH negative. So after H positive you can pick any of the H positive, but out of sulfoxide you have to pick only this part. So this will not go. So this will be a part of remaining solution. So remaining will be what? H2SO4 again. Remaining solution will be H2SO4, and the electrolysis occurring more or less of water itself, and that's why the pH of the solution keeps on decreasing. pH comes less than 7, solution becomes acidic. You can also write the equation at the rate anode. What happens? Sir, oxidation occurs. Whose oxidation we have to take it? Sir, of course 4OH negative. Oxygen from there to 0 we have to reach, right? O2 plus 2H2O plus 4 electron, and at the rate cathode. Okay, what we are having? H positive, so 4H positive plus 2H2. Anyways, you can see that it's not electrolysis of H2SO4, actually it's an electrolysis of water only, it's taking place, H plus and OH minus only. But yes, if you reach to the higher concentration of sulfate ion is there, let's say very high concentration, concentrated H2SO4 has been used, then in that way H positive, OH minus are very less, and this SO4 minus are attached, giving you S2O8 negative ion, which is called as what we call it, this is called as H2S2O8. Marshall's acid we used to call it, peroxy disulfuric acid. This is basically peroxy disulfate ion is there, S2O8, but that happens at see, this is the JEE Main 2025 question I was talking earlier about. So that whenever it is giving to you concentrated, okay, so which of the following can be used to prepare Marshall's acid, H2S2O8? So H2S2O8 has to be created. How you can create it? Either so we know that electrolysis of the dilute will cause you what? Dilute will not give you this. Dilute will give you oxidation of OH negative. But electrolysis of concentrated will give you what? Of sulfate ions, concentrated sulfate ions, and that will make you. So this is what I'm trying to say, that whenever we undergo electrolysis part, electrolysis depends upon so many things, upon concentration also. So higher is the concentration, more will become the chance of something getting closer to the respective electrode, getting diffused there. And now very much clear. I think this part is absolutely clear to all of us. Using inert electrode, so type of electrode also depend like what product of the electrolysis will be getting. So type of electrode is also one of the factor. Let's say we are using inert electrode. We know that copper sulfate in its aqueous solution produces two type of ion. One of them is copper 2 positive, the another one is sulfate 2 negative. This is aqueous, this is aqueous. So that's how our reaction is written. And also water molecules are there, which will also be giving you H plus and OH negative, aqueous and aqueous, and this is a water liquid. So overall, who is the winner here? Copper has higher reduction potential, it will go. Sulfate and OH, hydroxide will win, this will remain down. This remaining solution, can you see what is the remaining solution? The remaining solution is H plus and sulfate minus. So this is what we call as the remaining solution, which is sulfuric acid H2SO4, and this is what makes the solution acidic, and thus the pH will remaining as less than 7. That's it. At the rate anode, you want to see the reaction. Anode always occurs with oxidation. 4 OH negative ions will come, will produce 1 O2, will produce, okay, you also have to you also need to write down every equation so that you become comfortable while writing the equation. 4 electrons will be lost. At the rate cathode, we know what happens, reduction. Copper ion, which also are called as cupric ion, Cu2 plus, 2 Cu2 plus will come, acquire 4 electron to get converted to Cu, and that's how it works. This is your, but if we are using copper electrodes there, I told you that this is also reaction and like inert, like electrode dependent process. It depends upon electrode also, concentration also, medium also, so many things are there. Electrolyte also what we are drinking. So everything is dependent on that. So now we see aqueous copper sulfate. So guys, at the rate anode, what happens? Oxidation, where Cu, solid, where is it coming from? From electrode, it is getting diminished, causing Cu2 plus aqueous along with 2 electron. And what happens at the rate cathode? This process is used in the mineralogy or extraction of copper, where electro refining is done for copper, impure copper. So this was your impure copper. This is impure. Then copper 2 positive plus 2 electron gives you Cu. This is coming from the solution, from electrolytic solution, and then this is actually what? Pure copper. So that's what the reaction occurs. But when we use copper as the electrode, so please read out all these processes carefully, one by one, and then get confirmed with the product. Then HNO3, homework. Rest everything is very easy. Try this question on electrolysis of dilute sulfuric acid using platinum electrode. The product obtained will be what? So sulfuric acid, anode, oxygen gas will be obtained. SRP value of Mn plus 4 metal are these. The sequence of deposition. The deposition sequence is directly proportional to the SRP. If we are talking about at the rate cathode, so higher is the reduction potential, higher is the tendency to get reduced. So where can you find it? I think A, B, C will be getting fastest, and C should come at first. I think this is correct. Which of the following reaction is possible at anode? What happens at anode? Always oxidation. Where can you see oxidation? Something is going from positive 3 to positive 6. Yes, it can happen. Something going from 0 to -1. No. Reduction. 0 to -2. No. And that's it. A is the correct answer, right? Copper, if platinum electrode were there, copper was deposited at cathode and oxygen was liberated at anode. So this is correct. And if we are using copper sulfate with copper electrode only copper will be deposited, copper will be dissolved. So B is the correct answer. Impure copper at anode was dissolved, pure copper at cathode will be deposited. Then we have come to Faraday's laws of electrolysis. And before starting them, let me let you just read out this properly and then start this very soon, okay? So what is this? There were like two rules that we have to understand. One of them is called as first law of electrolysis, and first law of electrolysis, they said what is the mass of deposited substance, let it be a gas, let it be anything, it is directly proportional to charge. Q is the charge, and charge can also be explained into I multiplied by T, where T is the time, I is the electric current. So the proportionality constant is Z. W is equals to Zi T, Zit. So these are two formulas that we have to keep in our mind. And what is this Z? Z is also called as the proportionality constant, and we also call it like electrochemical equivalent. Electrochemical equivalent. How is it calculated? So Z is equals to E divided by F, or we can also say molar mass upon N factor into Faraday. So guys, that is what we have to basically learn. There is a practical significance of the same concept also, but now we are not in the time of solving the practical significance. We'll directly pick this formula, we'll try to apply it, and then I'll take you to the, so let's take this example. There's a one electron we can see. So mass of silver deposited will be how much? ZIT. Z is what? The molar mass of silver, 108, divided by N factor is 1, multiplied by how many electrons have been passed? 1, 96500, into charge is, let's say Q is the charge passed there. So this is the Z we can find out. We also can find out the current efficiency, that how much is produced, how much expectedly it should be produced, into 100. So that is what it gives you, percentage current efficiency. How much is the charge present? 96500 coulomb, 96500 coulomb. One question, number of electron delivered at the cathode due to electrolysis by electric current of 1 ampere in 60 seconds, and charge of electron. This is very simple. Q is equals to what? N times of electron. So N will be equals to charge upon charge of electron. Total charge is 1 ampere, 60 seconds, 1 into 60 divided by 1.6 10 to the power minus 19. So that is the number of electron that has been asked. Now you can find out by your own. 0.1 mole of MnO4 2 minus, which is permanganate ion, is oxidized. Is oxidized. Passing the electricity from this to this, something is happening there. I don't know what is it. Okay, this is not permanganate ion. This is actually manganate ion. So MnO4 2 negative accepts how many electron, by the way? It loses 1 electron. MnO4 negative plus 1 electron. So what has been asked? If this is 0.1 mole, this number of electron will also be 0.1 mole. Without undergoing any calculation, we can find out that how much electricity is needed. So electricity will be charge will be 0.1 into Faraday. So 0.1 into 96500 Coulomb. So 9650 Coulomb is answer C. Anyways, now we'll directly take you to the. You can do it by your own. Some of the good questions are there. The practice session is conducted tomorrow, so you are most welcome. So please read it out. Allow me a sec. You first read it once, then I'll come back and join you. Allow me a sec. Please read it out by your own. Yeah, guys, so I went to bring some water, and now we are on the edge of finishing this chapter. Now we'll be having just one more topic right apart from here, and rest the theoretical part I'll be giving to you. You better read it out. First of all, we have the second law, and as I told you, according to the first law of Faraday said that whatever the amount of substance deposited there, it's directly proportional to the charge passed. Okay, so was equals to Z into Q. W is equals to Z1 Q1, and Q is the constant. W2 will be equals to what? Z2 Q. We'll divide them and we'll get it. W by W2 is equals to Z1 by Z2. But we also know what is Z1 and Z2. Z1 is actually E1 by F, and that is actually E2 by F, which is equivalent mass by Faraday. So that's what we get the second law. What second law has to say? That the mass deposited of two substances when the same charge is passed will be directly proportional to their equivalent mass, or we can also say this will be E1 by E2, or W is equal to E. So that is it. So we'll take you directly to the questions, some numericals. One question I'll do it for you, and then rest I'll be doing on my upcoming session only. There's a factory which produces 40 kilogram of the calcium in 2 hours by electrolysis. How much aluminum can be produced by same current in 2 hours? Okay, so it produces 40 gram of calcium in 2 hours. Aluminum needs to be done. So mass of aluminum need to be calculated upon mass of calcium is equals to E1. E is 27 by its in factor is 3, and in fact this has molar mass of 40. N factor is 2. So mass of aluminum deposited will be what? 9 by 20 into 40 kg. So this will be 18 kilogram. I guess 18 is the correct answer. Can I check? 18 is correct. You do it homework. And that is also, I'll give you its homework, and I'll reveal this question in my upcoming session that is going to happen tomorrow. Then we have conduction. Okay, so we are now preparing for our JEE Mains attempt 2 as well as advanced, and we want every topic to be finished on time. So there is something that I can help you with, and there is something that you can help you with. You yourself can help you. So wherever there is a theoretical basically go through of the chapter or the concept is required, I'll let you know, and wherever it's needed and I must explain the concept, I'll do it. I'll also make some of the questions on the board, but I will expect from you that rest of the questions and practice part will be conducted tomorrow at 10 o'clock. The link is given in the description, guys. Go now and enroll yourself. Okay, go and notify. Then we have conduction. What is the meaning of conduction? Conduction is a property which is a reverse of the resistance, an ability of a substance to allow the passage of electric current through it is called as conductance or conduction. Sorry, not conductance, called as conduction. And there are like 3 substances. On that basis, whether someone can, how much of the electric current can someone pass, we have 3 major categories called as conductor, insulator, semiconductor. What conductors are? They have their electrical conductance from 10 to the power 4 to 7 ohm inverse meter inverse, 10 to the minus 20 to minus 10, which is very less, that is for insulator. And semiconductor has in between of insulator and conductor, which is 10 to the power minus 6 to 10 to the power 4. Conductors have higher electrical conductance, insulator have very low, and semiconductors have in between. Not required, don't come with the doesn't come with this exact data, and this data might have been like you might have visited this data in 12th, I guess 12th class. There is a chapter called as current electricity. There also we study the same, but not required as such data wise in our segment. Just giving you an idea, there are three types of substances: conductor, insulator, and one of them is called as semiconductor. Semiconductor is like in between of conductor and insulator. So conductor are the substances which are classified into two categories. One of them is called as metallic, another is called as electrolytic. So metallic conductor, what does metallic conductor have? Metallic conductors are all the metals. Electrons are the actually charge carriers there. Electrons are the one which are transferring the electrical charge from one place to another. And with the flow of electron, the opposite electric current flows. Another one is called as electrolytic conduction. Electrolytic conduction, we have an aqueous solution in which ions are there, just like aqueous NaCl. We all have come across like water, normal water, what should I say, distilled water. It's not a good conductor, but yes, water added with some electrolyte, let's say NaCl. It's an excellent conductor. What does the conduction comes from? It's because of the movable ions in there. So in electrolytic conductor, the conduction is because of the movable ion, which is called as mobile ion. And in metallic wire or metallic conductor, the conduction is because of the mobile electrons. Please read it out at once, then I'll give you the next idea. Success in our DNA wanted to talk to me. I don't know why did he deleted some messages. Not a problem, by the way. So guys, read it out once that all metals are a part of metallic conduction. Electrolytic conductions, we have electrolytes such as salt, acid, base dissolved in water. Their aqueous solution will work as electrolytic conductor. Metals have electrical conduction due to place to the mobility of free electron. And they have due to the ions. No chemical reaction occurs in the metallic conductor. But electrolytic conductor, there is a oxidation at anode, reduction at cathode occurs. Metallic conduction decreases due to increasing temperature, because on increasing temperature, electrons and mobile kernels start vibrating. Mobile electrons reach toward kernel, which are metallic kernels, simple holes of metal ion which have lost their valence electron. Valence electron are working there as a carrier, charge carrier, but they meet accidentally. The metal kernels on vibration meet accidentally with the electrons, and this upon higher temperature basically happens very frequently, and that's why the resistance increases, conduction decreases. So conduction decreases with the increasing temperature. But in electrolytic conduction, the ions which were already available increase in the number, because as the temperature increases, the degree of dissociation of an electrolyte increases, making more number of ions available, and thus the electrolytic conductance increases. So that is it, guys. That's for both of them and their differences. I'll take you to some simple calculations and simple things, but no need to look at out these things. I'll simply give you an idea like how does it work. First off, very on Ohm's law, that resistance is equals to direct proportional to length, inverse proportional to area of cross section. So it becomes rho L by A, where R is resistance, rho is resistivity or resistance by 1 unit length and 1 unit cross section, or we can say 1 unit of our electrolytic conduction, electrolyte, 1 ml of electrolyte. R is equals to this. You reverse this equation, it will become 1 by R is equals to A by rho L. Guys, this L by A is also written as G star, means cell constant. So the formula becomes what? 1 by R is called as G, conduction or conductance. 1 by rho becomes kappa. Kappa as in conductivity or inverse or resistivity or specific conductance, and K upon G star you may write. L by S G star. Got it? There is one more electrical conductance that we study about called as the lambda. Lambda is your molar conductance. Okay, lambda at any concentration C can be written down as 1000 into kappa divided by molarity of an electrolyte. Okay, but again make sure that everything whatever you're taking, your kappa should be in ohm inverse, centimeter inverse. Conductance what we are getting is ohm inverse or Siemens or MHO or anything you may call it, Maho. Then lambda has a unit of ohm inverse of Siemens, centimeter inverse, mole inverse. Very simple to solve with. K is actually your Siemens centimeter inverse. Molarity is mole per liter or per centimeter cube. The per centimeter cube goes up. Centimeter cube upon centimeter is centimeter square, mole inverse. Very simple. So just go through all over it, and then I'll directly take you to some numerical part. Please guys visit it, and then I'll take you directly to some numeric solving part. Now we'll go to some numeric solving part from here. Let's take this example where a question is already given to you, so the answer is also given to you, not a problem. We'll directly reach to some of the good questions. That's a good question, by the way. Let's see this question. And this is the high probable question, may come in your second attempt. The resistance of 0.2 molar solution of an electrolyte is 50 ohm. Specific conductance of this solution is 1.4. So this will be helping us to find out the G star, because the same solution, same electrolyte, this conductor is here, same setup is used. Length and area of cross section of the plates are the same. Maybe you are changing the concentration or we are changing something else, but yes, we can write it down that 50 ohm is equals to Siemens meter inverse. Okay, so 1 by rho, so 1 by 1.4 into L by A. What is the length, by the way? Okay, L by A is something that we have to find out, G star. So this G star will be equals to what? 70 meter inverse. 70 meter inverse. Okay, I can also make it accordingly, because ultimately I have to find out delta, lambda. So this can also be written as 1 meter per centimeter will be like 70 by 100 centimeter inverse. 7 by 10, 0.7. The resistance of 0.5 molar solution of the same electrolyte is 280. So using that I can find out the value of kappa 2. So resistance is equals to kappa into L by, not like that, 1 by kappa into L by. So resistance is how much? 0.5 molar is 280 ohm. 280 is equals to how much is 1 by K? That we have to find out. L by A is already there, 70 by 100. So everything will now come up in centimeters and all. So that's why kappa will be how much? 1 by 400 ohm inverse, centimeter inverse. Otherwise it would have come in meter inverse, but we need in centimeter, because our formula of calculation of lambda comes in K into 1000 by M. So there we can put this value of K, 1 by 400 into 1000 by molarity. How much is the molarity? 0.5 molar solution. This is 200. This will come up as 5 centimeters square mole inverse. But again, the value has been asked in these formats. So I'll convert down into meter. How to convert in meter? Or lambda will also be equals to 5 into, this is centimeter square, convert it into meter. So I will write it like centimeter 1 by 100 meter square mole inverse. I think this is the correct answer. A is the correct answer. Questions are easy, but the only thing which is difficult is their application. So you know how to apply them, and you will become as much as confident as I am. And it's very easy actually. Okay, another question is there, and we'll practice more or less questions in our next shift, by the way. So guys, we also have one more concept called as effect of dilution. So dilution, whenever we do the dilution, the conductivity kappa is defined for 1 unit volume. On dilution, volume increases, number of charge carriers or ions per unit volume decreases, but again we have to find it for one unit only. So we can say that kappa decreases with dilution. But what about what about the molar conductivity? Lambda. So lambda is defined for 1 mole of electrolyte whatever is the volume. So let it be whatever be the volume is there, we have to identify everything for. Getting me? Now I'll do one thing. So on dilution, volume increases and degree of dissociation also increases. As the degree of dissociation increases alpha, number of ions increases. Number of ions from 1 mole of electrolyte increase. Thus, what we can say that yes sir, on dilution lambda molar increases. On dilution, that's it. So guys, you can also identify the lambda value at infinite dilution by simply following Debye-Huckel-Onsager equation like this. Might have seen this equation. So this is root C versus this. Okay, but problem is, so the problem is this is only applicable for a strong electrolyte. Okay, strong electrolyte like KCl, sodium acetate, NH4Cl, whatever the strong electrolyte are there, strong acid, strong base, or either one of them is strong and their salts. But this is not applicable to up to weak electrolyte like CaCCOH, because it becomes what? Parallel to the y-axis, and even upon extrapolation you can't reach towards the y-axis. That's why you cannot find out the value at infinite dilution. For these, which we use Kohlrausch law of infinite dilution. What do we use is Kohlrausch law. What does Kohlrausch law has to say? Kohlrausch, look, where is Kohlrausch here? So yes, this is Kohlrausch law. Kohlrausch law simply say that, let's say if AB is an electrolyte, so if we have to go for infinite dilution, let it be a weak or strong electrolyte, let it be weak or strong electrolyte. If we have to go for 100% dilution, or which we are bringing its concentration to 0, then it doesn't matter it's a strong or weaker, because lambda infinity or not of AB will always be equals to lambda of A, let's say N positive, and then lambda of B in negative, like that. This is what Kohlrausch had to say. बस खत्म होने वाला है लेक्चर तो दोस्तों, लेकिन what I can see is के it's a huge chapter, by the way. So when we started this chapter, we had a very clear mindset that we are going to finish this chapter in coming 4 hours. But now once we are reaching towards the completion of 4 hours, 8 o'clock will become your 4 hours. We can see that few of the topics have been remaining, but not a big problem anyway. We have a theoretical part remaining from here, which is your just a lookout part. Corrosion of iron, corrosion of metal, one of the part. degradation of metal. The another part will be about batteries, primary and secondary batteries, and few of them are pretty important. As we have seen it at the starting of this lecture, we saw the syllabus and we found that it's not very easy to do. We'll make it anyhow. So now I'll take you to the next question, everyone. So the limiting molar conductivities of NaCl, KBr and KCl are these. Then lambda naught M for NABr. So lambda naught for M for NABr will be what? It's very simple, yeah. Lambda naught for whatever the constituent you see, NABr, just add them. Add them. NaCl, KBr, and subtract the one which is not required. Like Cl is not required, K is not required. Lambda of KCl will be subtracted. That's how you can do. And further questions I'll be bringing the further questions for tomorrow. And please don't forget to attend my tomorrow's session. Gonna to be very important. And there only we'll be dealing with the remaining part of this chapter, which is this. How many are? This is batteries and corrosion. So anyways, this part of the chapter will be covered in tomorrow's special session. The link is in the description, and 10 AM our lecture will start.